Hello, everyone, and welcome to my stream today. All right, come say hi in the chat if you're here, if you're alive. I know it's been a few weeks again. I've been traveling. Mm. Uh, couldn't do it. Couldn't go like 2 seconds without making that joke. Suspense puns are almost as bad as solid puns. All right, there we go. See, it's funny when you're streaming because you'll say something, and then there's naturally going to be a delay before people see it, and then naturally going to be a delay before I see the response. So it's always kind of funny because there's always that moment where everything starts and you're just a little bit behind the eight ball, so to speak. Um, anyway, glad to see everyone's doing good today. All right. Hey, good. Glad to see everyone here. Yeah, it's been a while, hasn't it? Um, I did, family vacation, went to like Disneyland and stuff, and then I went to Amsterdam for React Summit, which was fun. I actually gave the opening keynote at React Summit, which you might not expect the creator of Solid.js to give the opening keynote at, what do they advertise it? The world's biggest React conference. But here we are. I think it was a good talk. If you haven't seen it, maybe it might be worth checking out. I mind you, if you're a regular watcher of the stream, you've probably seen a lot of the content. I don't know if you guys remember, like 4 months ago, I did the front end essential crisis stream. It's like a 5-hour stream. I tried to condense that into 20 minutes. That's pretty much what my talk is about. Yeah, you liked it? Yeah, no. But it also meant that I was right there on the ground floor, well, when everyone was realizing what was happening with Suspense with React 19, which was an interesting experience to say. So I had some insight from, like, I was in a meeting where they had a bunch of library maintainers all sitting around, talking about the future of React. That was the whole idea. And this just dropped. And basically, I kid you not, the room, like, basically there's other topics, right, that people wanted to talk about. But like it was like 70% wanted to talk about the suspense thing, 30% the other topics. And like after, a short realization and working through it, I think someone made a joke that it was like a support group. To be fair, one of the other topics was how to communicate better with the React core team to get so I mean, it wasn't even completely unrelated to the whole thing. I think that is a challenge, right? When you're steering the ship of something as large as React, you know, how all these things kind of come together and how to kind of like deal with a wider ecosystem that's not going to do things exactly the way you expect. All that being said, the suspense topic in general is super interesting because I will say it was interesting to hear people from Meta side, especially of the React team, talking about what they do when using React and Meta, which to me, and I'm hoping most of the people on the stream, is like the obvious thing people should be doing. But the discourse that we see on platforms like Twitter lead you to thinking that it is something else going on, right? There's all these people like, oh, I need to co-locate my data fetching and all this stuff, but they don't even do that at Meta. So they actually hoist their fetching up because that's the only logical thing to do. So we're going to talk about that a bit today. But first, I probably should tell people that I'm live so they can get past that Twitch pre-rolls. Hey. I think the new compiler with the new developers thinking in React after hooks. What do you think? It's an interesting one. I mean, I got a chance to talk with one of the authors of the compiler when I was there, and there's a lot of really cool things about the compiler. But this is one of those things where like the technical aspects of the compiler are pretty impressive compared to compilers that we've seen released to open source. I've seen some compiler projects that have not been released to open source that are equally or more so impressive, ones that I'm not allowed to talk about. But I don't think it's so much. The challenge here is effectively for the developer, there's a nice DX story here. But it from like the DX story side, I don't feel it's revolutionary compared to say what we saw in Svelte 3 years ago. So it's kind of like technically it's more interesting, but effectively maybe not. I guess we're gonna have to see. Like, I think it's kind of cool that people perhaps can just write really simple code. You know, stuff like where they don't have to be as aware of things at first and get good results. So it pushes off optimization, which I think does make it a big deal. But on the other hand, like, so what? I mean, I don't mean that. It's just like I never cared about Svelte for its syntax. I never cared about, you know what I mean? Like, if you don't care about that side of things, mechanically, you know what I mean? Like, if I'm gonna write optimal React code, I'm gonna write optimal React code. It might help. It will help a lot of people write more optimal React code without realizing it. But it's like, what does that even mean? Well, I talked about the compiler a little bit previously, and I think there was one update since the last stream. But before, I don't want to tangent too hard. I mean, let me see if I can share my screen. It's been so long that I don't even know if it's going to let me present my screen. Give me without like restarting the. See if I can share my entire screen over here. Let's share. All right, let's yeah, we're in, right? Because if I go to my profile over here somewhere, and I think I had one comment about the compiler since we last streamed. Yeah. If you remember last stream, I I went on the stream and I actually built a benchmark with the new React compiler and we tested it on stream together. After the stream, I realized that my depiction of the compiler wasn't fair. Right? And the reason it wasn't fair is because I was comparing something that actually I originally wrote a very hand optimized version. And in fact, when I originally wrote it, I was hitting some questions and design things. And I actually reached out to Dan Abramoff and he actually helped me make it even better against like the compiler doing something against some just random React code. The random React code wasn't completely unoptimized because structurally it was still set up the right way. But like, yes, obviously my hand optimized code is going to be better than the compiler. So instead, I was like, what if we had a third option that I didn't test on stream, which is a no compiler option? So we basically have hand optimized by me, purposely remove the optimization version, so still like semi-optimal with the compiler, and then that version without the compiler. And that's a bigger spread, right? I know we were going to talk about suspense, but we could talk about the React compiler for a bit. Yeah, you're right. I need to actually tell people that I'm live here because we're jumping right into it. Give me 2 seconds, then we'll talk. We'll continue this conversation. Let me get back to my profile here. Whatever. God, I'm the worst. I am definitely getting as these user interfaces are changing. I am definitely feeling my age coming in because I think this will happen to all of you one day. But over time, it doesn't matter how quick you are on the draw today. Double check that I'm on. Yeah. You will get to a point where you just get less able to change in your ways and you'll get accustomed to previous patterns. And then you will definitely unfortunately start having harder times with stuff that you've always considered incredibly easy. Anyways, should I say anything else other than I'm live? Talking, compiler, and suspense. Yeah, let's make it. Yeah, let's make it a little spicier. All right. Thank you for reminding me. Yeah, so anyways, where I was going with this is so we don't like get pulled completely off the whole stream on the compiler stuff, but it was a good place because it's right where we left off on the last one. What to say on stream? I compared thing. However, I went back now and compared non-optimized code with the compiler turned off, and this was more illuminating. Okay, just what's cool about this benchmark is we saw that the compiler version on the stream was like slightly slower on some of these things, but I managed to like it's nominal, and it isn't. And after I did the test run without a bunch of background processes, my computer running clean and stuff, we still saw this small split. But yeah, stuff like select rows and was particularly different, swap rows. But if you look here, if on the third column, let me see if I can blow this up for you because I understand that this is not it's tricky. Open image in new tab. There we go. Is that better, guys? But if I remove the compiler together and I don't do the hand optimizations, stuff like partial updates, things where you're doing, more fine-grained updates, stuff like select rows, doubled, swap rows, remove rows, basically every part of this got slower, and it's a more sizable on average, right? Because if React is 50% roughly slower than vanilla JS, in this scale, keep in mind there's always a scale to consider. And here, without the optimizations, and keep in mind this isn't much application code. This is just down to the metal sort of, you know, you know, basically everyone has the same DOM overhead. This is just really pushing the it's like amplifying on the overhead of the framework itself, essentially, right? When you're looking at it relatively, because everyone has to do the same DOM work. And this has basically no app code. There's a sizable improvement that the compiler gives you for free, essentially, right? So I mean, this is a pretty impressive scale. I'd take this if I didn't have to worry about this at all, right? It's one of those challenges where, because like use memo, for example, doesn't go away with the compiler. Like, yes, you don't need to write it most of the time, but if there's something that's expensive that should be memoized, you still might have to manually do it. The compiler does its like I think there was an exact example, and they're working on this to improve it, but where like there were cases where you'd still need to use memo if it was very important to save certain calculations. That was from the React team themselves. I don't know if stuff has shifted over time, but I'm just like, keep in mind that underneath every good abstraction is the truth. But in any case, we can see here that when we, instead of comparing the compiler against optimal hand code and instead against completely unoptimal code, we can actually see a reasonable performance improvement from the compiler. And when we look at stuff like memory usage, the compiler was the highest out of the three in terms of memory usages, but this didn't make it nominal. Like, it was nominal. It didn't make a huge change over React. Like, the hand optimize also was slightly higher memory for certain things. But it looks like, yeah, for some reason, this is an interesting metric. I don't know why no compiler would be, I guess because of all the extra crap it has to create when it's like updating rows, it actually has worse memory characteristics. But generally speaking, the memory overhead is not that significant. And then when we talk size, this is what I screwed up on stream originally because I didn't have everyone on React 19. This is a small app. So this scales probably a bit differently, but basically no compiler, 179.5. Manually, I added 0.1 kilobytes, and then it was only 2 kilobytes more uncompressed with the compiler. And once you compress it, into reasonable size, because React itself is about 42, 43 kilobytes. The app's probably less than 5 kilobytes. You can kind of see here that the difference between no compiler and hand optimized in this case isn't even difference, and the compiler basically adds 1 kilobyte. I mean, if you looked at the application code, you could argue that that's perhaps like a 20% code increase, but I'm not ready to make that off the single test. Anyway, hopefully food for thought for people. Yeah, I mean, I had an interesting question when I was talking. I can never pronounce his name properly. The guy from the React core team who was at React Summit. And I was like, I've been having a hard time showing people the difference between fine grained updates and the compiler updates. And like the React team kind of prides themselves in this. They think like, because in the sense the compiler is really clever, that it's very hard to observe the difference. There is an actual difference in execution and rendering in like difference between Solid and React. But because of how the compiler handles side effects, it's almost impossible to actually show it. If you try and observe side effects in the compiler, React will log stuff as if it's rerunning everything all the time. So all my clever tricks to try and show exactly what's running or not running is basically doesn't work. The only way to make it work is pull it into the graph, have it be a derived value. And that defeats the point of what I'm trying to show. I'm trying to look at the overhead of the framework mechanics itself rather than like your application code. I want to show what's actually running from the framework standpoint, and they make it almost impossible to show it. So like I think this is like makes sense because a lot of these side effects they can even just tree shake out, but it doesn't let me like, what's the term, like when you put a spy in there or like monitor the actual behavior as easily as like as a layman dev just trying to come in and see what's going on. So I think that's the way it probably has to be, because I think as a developer using this technology, you're not supposed to really understand how it works, right? They don't want you to be able to breach the abstraction. I once made a comment that I said the problem with use effect was that was the first moment that people understood how React actually worked, right? Like until that time, they might have had a mental model that hooks are kind of like signals. But the second they understand see use effect, that layer between the abstraction and the metal erodes away, and then and suddenly they're like, oh, that's how React works. I think if you provide an abstraction that is non-introspectable, on one hand, you can say it's magic, but more so, it then becomes the baseline. There's nothing to prove otherwise. Do you know what I mean? Like, so like, I think it's clever because as long as it works properly, it becomes the new mental model, so to speak. Like, basically, if you can't look under the hood, then there's no big reveal. So I don't know. Take that as you will. This is like an Eminem reference. I guess I'm old enough for that. I agree. Yeah, but like, do you care? You're saying it's weird you don't know what's optimized, but like, do we really care? I think the average developer shouldn't. I think so. From that perspective, React compiler is pretty cool because it raises the floor significantly on what you can do with React. It does not raise the ceiling though. The ceiling stays the same. For all those people who are like, oh yeah, now React has signals, it's like not even freaking close. But like, does that matter? I I don't know. If the performance is good enough for you before, I'm assuming it's going to be good enough for you after with the compiler. Hiding internal selects for library devs or energy. Well, yeah, right. This is where you can start getting to the friction with the library devs, right? Because there's different levels. When I talk about developers, I'm talking about like people who are application developers. Library devs like being able to have a little bit control and understanding what they're doing. They want to be able to create the most optimal thing themselves. It's a hard pill when React's like, "Don't worry, we'll take care of it." And it's like, "Do I trust you? You've said that before." You know what I mean? Like, you actually see this a lot. I forget where there was a comment. Maybe I bookmarked it, but like if you listen to like Tanner or Ryan Florence or someone, let's see if I can find my notifications here. No bookmarks. Yeah, if you listen to Tanner or Ryan Florence talk, yeah, I got one here with Tanner. Do I have a Ryan Florence one anywhere? Maybe not. They keep on talking about how fine grained like check out this new fine grained thing that I'm doing, right? And it's like they had to work against the React status quo to get there, and they're really happy about mechanically doing that. Where the React team is kind of like, don't worry about that. Yet they are actually working really hard on that. Ryan Florence, I forget where. Yeah, he was talking about some fine grained router data validation thing. I think I was reading that stuff and Tanner stuff, and I keep on coming back to the fact that like, I mean, Tanner's is right here. You know what? Let's use TanStack query instead of the router's built-in loaders with zero sacrifice to SSR. Picture teaching the router how SSR client query, route plus query, serialized query on every client. Pretty sweet. We're about to take it even. What? Show more. Yeah. Take it even further with the ability to stream non-hoisted use suspense queries from the server to client, then seamlessly hydrate them automatically. Take it all the times now. Okay. And I'm like, I understand why people are excited about this. How many likes are on this one? 280. Yeah, this is exciting. But it's like this is the way Solid's been working for 5 years. To a certain degree with create resource. So it's like, I, it's like, I don't know. It's funny. The library authors seem very much more in aligned with where we're sitting, and then yeah. I wonder how this tension plays out because I said that there's a Ryan Florence tweet. I don't have it bookmarked where he was basically talking about fine grained updates as well for Remix, and I'm just thinking, like what's pushing this? Right. What Million.js and they could, right? Because Million.js, and we saw Aiden actually on stream. I was a moment ago. I highlighted one of his comments, and the compiler are almost like passing ships. Like I said a while ago that I didn't think the compiler was going to win any benchmarks, but Million.js wins every benchmark. You know what I mean? And it's just because like it's quite possible that React in the future does try and optimize some of those areas, but like they also had Dominic from Inferno in there, kind of optimizing along that same vein, and I mean this remains to be seen, but they said that the structural stuff, the stuff the compiler fixes, that part where from application code, they're like most people's apps are actually a lot of application code, and that application code is actually what slows down the apps. So the fact that frameworks can render a couple tens or hundreds of milliseconds faster, certain things doesn't matter as much as your application code. So like we're not going to prioritize or do trade-offs based on being able to do like these render techniques. Like some of the optimizations that I think that Million does might be challenging for their concurrent model. I don't know. Aiden can probably fill me in on that better, but like essentially they went and they tried Inferno, at Meta, and it was faster some things, some startup time things, but it barely made a dent. and then they were like, okay, we're going to go this concurrent way of, and kind of take things, the other way, because if we can schedule or manage the application code, we can deal with the parts that people can't control. It's the same strategy with the compiler. We can make the unoptimal code people write better. That'll have a bigger impact than making the framework faster. I think that's generally their thinking. But the question you should be asking yourself in this scenario is, how much of that is due to the actual architecture pattern of React itself, the VDOM, the re-render? How much of that overhead is inherent to that model? So like that I mean, it's unanswered, right? To a certain degree. But that's where I'm coming from when I'm looking at these things, because if the model is inherently expensive and then your app code ends up just magnifying that, then yeah, I think if you want to keep the model, then you have to deal with that. But if we're talking about something else, then like maybe there's other directions you can go, right? Because Million's direction largely is taking a page from what Lit or Solid did, which was like, let's optimize the pure rendering, the not pure but like the creation stuff, our ability to just like very quickly generate large blocks of code, right? Or view. React prides itself on having the first run be the same as the second run every time. And we're going to talk about that today, actually. We're going to do some coloring. I called this stream the Art of Suspense. You'll see why in a little bit. I mean, sure, out of the box. But for me, when I'm talking about that, I'm talking about like they're raising the floor. Like it's going to be much harder with the compiler to write truly inefficient React code. So they are definitely raising like the floor of the performance. It's just like, yeah, I don't know. But in reality, the production use case. Okay, yeah. Did I miss any of Aiden's comments? Yeah. In reality, the production use case for fast DOM updater tool is very small. Oh, what do you got for me, Aiden? Is this a Dominic post? I will take a Dominic post. Give me a second. I saw this. I even bookmarked it. I was going to talk about this, but you're right. The compiler is a good time to talk about this. JavaScript compilers today are fixated on compiling individual modules. That is sensible and deterministic property, but really the true power of compilation is cross-module. Oh, he's gone here, hasn't he? I know there are some cross compiler libraries in JavaScript, or cross module compiler libraries in JavaScript right now. I worked on one for a couple years. It still not released because of complications there, but Marco 6, which I'm not supposed to talk about, is a cross module compilation system. That's how they can trace reactivity through the whole thing. Imagine being able to inline components that you used once, including their props. You could even inline well-known props on init, remove entire chunks of code due to dead code elimination. You'd even argue that there would be no need for something like RSC, as a highly intelligent compiler could do all that work for you, remove the limitations, refactor your code to make it work. The drawback is going to be debugging experience. The more quality does the developer doesn't expect, the harder it is to reason about some bugs. It's solvable, though, as has been shown in other languages. I'm with him up to the RSC comment. Like, I get what he's saying, but the data fetching RSC thing specifically is a pain in the pain, because I talked about this in my talk. There are some things that we don't know whether they are implicitly server or not. And even the smartest compiler can't make that decision point. Like, I've worked on resumable systems, and this is what he's describing is basically how, like, Quick's resumability isn't cross module, but Marco's is. And the biggest difference between the two because of that is that Marco can confidently tree shake out the code where Quick just bundles it separately for you and it might never get loaded. But the key here to understand is that both of those um, architectures have to include the potential of any code coming in below a decision point, which means that any data that you need to serialize, you have to serialize any data that could be read below that decision point. So, like the island architecture, the clear boundaries of like use client or Astro's island syntax or whatever it is, actually are important to actually accomplish what RSCs do. An automated compiler can't do that. I don't think it can solve the data serialization problem. It doesn't know. It's kind of like this, similar to that problem of like showing the CSS on the page, like how much CSS inline, like the part. There's people trying to solve the like initial CSS, so you only show what's on the page and then load the CSS later. We start getting to this area where it's a lot easier for a human heuristic to be like, you know, this component generally appears on the page at first and pull that in. It's a lot easier for us to go like, I think I actually had a conversation with Adam Rakis the other day on Twitter too, where he was talking about data loading, and he was like, you know, wouldn't it be cool if something went down and then basically anything that was static, pull out that data fetch and have it hoisted, but anything below a decision, then it can be loaded later in the client or whatever. And it's like, not necessarily. That decision point doesn't define whether you actually generally want to always load it. Like, what if the decision is 99% one way and 1% the other way? Like, even creators of things like Quick understand that, and they were trying to use AI intelligence to look at end user usage to determine how to branch on those paths. But there has to be more than just the static analysis of the compiler. There In order to accomplish these sort of things, there is actual a real decision point. You could try and use, like, as I say, AI models and analytics and stuff that kind of come in, but the compiler itself is insufficient, at least to be able to handle what I call the RSC problem. Without like the automatic part, without like some sort of, you know, like notation or something. But yeah, the inlining thing was interesting. I talked about this in an article about 5 years ago because in order to get to a point where you can inline, I was saying like components have to basically be functions. Like you need to get away from them having instances. And like, so when I was designing Solid, I was very much thinking about it. Dom working on Svelte 5, which is kind of like Solid, I can see why he's here again. I mean, to be fair, he did some of this work in prepack as well. But like, I think he's in a place where he could attack this inlining thing. But yeah, basically, I got to the point where I could only inline components in the same file module, and I was just like, "Is this worth it?" And I'm like, maybe like something like the JS framework benchmark, where you just put everything in a file. But I imagine with Svelte, this is uniquely challenging because Svelte is single file components, so you can't inline. You know what I mean? Like, so that's interesting. Yes, for suspense, and I haven't talked about that yet. And the answer is probably yes. I unfortunately, which means that RSCs have a lot more um, weight than you'd think. Yeah, it's cool, but as I said last time, I I kind of think Ryan Florence and crew are doing it wrong. I think Next.js is actually the approach that makes sense. I don't say that happily. It's just how I view the world. Tanner was posting some stuff too, and I'm like, they're kind of gone off this thing. I think people just don't get RSCs, and I think the thing they want them to be are not what they are, and I think maybe that's ultimately going to be their failing. But effectively, no solution out there, presumability, whatever thing, actually accomplish what RSCs accomplish. So yeah, yeah, even Marco 6. Marco 6 is a very smart resumable framework. It does not actually solve the RSC problem because you hit it the second you try and add client side routing back in. Seriously, if you guys have not watched my talk I'll post it again here. It is. I've talked about this on stream, so you guys should all be familiar with it. But maybe like having it like condensed and in your face is the way to do it. But like, yeah, let's just drop this one right in here. Don't leave the stream right now, but like, yeah, I mean, this is the kind of problem space. And keep in mind, I backed off RSCs for the solid start release, or not RSCs. I gotta stop saying RSCs. Server components in general, not non-React version. But that doesn't change my view of how uniquely powerful they are. Yeah, like from my view of the world, RSCs are just a more advanced lineage of islands, right? Whereas like presumability is trying to take our current app, single page app mentality further. Mostly, the funny thing is when you hit something like Marco, which is trying to not do that, so to speak, where they are actually solving for the MPA case, but just in the most optimal way possible, and they hit resumability as well. But the problem, as I said, is client side routing. Yeah, actually, maybe that's actually, it's so funny how that works. It's like Quick worked so hard on trying to keep the single app mentality, like like you're just writing something kind of like React with some dollar signs. Ignore those, right? But the truth of the matter is, like, resumability is like the ultimate MPA optimization, and it can't handle client side routing in an efficient way today. Whereas islands, which were the initial version of the MPA framework, been going on now for over a decade of islands, thanks to Marco. RSCs actually are an approach to solve the client side routing. So like, yeah. Yeah, I don't server data. I understand that's why they want to do it, like the relay perspective, but like, and that's one perspective of it, but it loses all the like finesse of it. I mean, if that's all you wanted with server data, then Remix is good. Do Lakes, Nuxt is good with their server component things. I just don't call those actual server components. It kind of misses the point. And the reason, when Waku came out and the React core team's like, don't do that, to a certain degree, just like let people just drop server components anywhere, is because of fetch waterfalls. Mutation waterfalls, people are more accepting of, but fetch waterfalls, where you have, if you start weaving these things through each other and they can actually pass props to each other, then you can't render one thing until part runs on the client, part runs on the server, part runs on the client, and it's just back forth, back forth, back forth. It's terrible. So like, yeah, I don't know. If you want to get stuff small and granular, your best bet is keep the outside of the onion as static as possible and push your interactivity to be as thin of layers as possible and as closest to the leaves as possible. Some things are not close to the leaves, but then make them a very thin layer and project the server back through them again. MPJ. Who's MPJ? Facts. Server, quick Astro this future. Astro doesn't actually solve the client side routing thing. Quick needs something like server components to kind of bridge the gap. Yeah, it's one of those really tricky things, because it's the reason why I started my research on the server component side, because the problem is it's even too late for us to a certain degree. It's much harder to get back to server components when you have a bunch of advanced features than it is to start with that mindset in mind. The reason that we didn't end up shipping something like server components in Solid, other than like some really odd DX issues, like where I was having a real hard time justifying the mutation story for apps and all that, and I couldn't unify it. But like from a pure like who cares mechanical standpoint, was that we had out of order streaming. Out of order streaming makes stuff drastically more complicated. I could picture how I could take Astro without out of order streaming and have a working islands router demo that would basically do the right things. Astro today, naively, like just using vtranslation, will fail. Again, watch my talk. I'll explain why it doesn't work for this. But I could see how you could implement something Astro like, or maybe a layer on Astro that could get you kind of in the way, and then you could try and get resume billing quick. But at a certain point, we have all these distinct pieces. We need these pieces to talk to each other, right? Like some of those limitations that Astro have is because it doesn't own the client side framework. So like React or Fresh with Preact is just better situated when we talk about an app context, because the state has to persist. I keep on getting bugs from people from things like Nano Store, and it's like you have to understand that like lazy hydration is not a sensible thing to be doing unless you can wake up as it goes, like as things change, not on some arbitrary thing. You have to make sure that you don't hydrate or initialize the app after any state on the client that it could read has updated. Now, Quick does that in its own world of things, right? But like, yeah, like something like NanoStore, the framework's not going to have the innate knowledge of it. So like, there's not an actual clear path forward right now where I can tell anyone go use this technology and you're future proofing. Everything right now is very temporary. It's very intermediate. That's probably why people are betting on React, because they're like, look, these guys will figure it out eventually. I don't care if the stuff is like super inefficient right now. Maybe one day they'll get there. History has shown us that that's not the case, but it might be different this time. Where's that meme? Could be different for us. Oh yeah. I saw that. Yeah. The funny thing is, I'm sorry. I actually don't even know what that is. My introduction to tech YouTube was Jason Langstorm, basically, and that's the only thing that I paid attention to. And then I saw Jack Harrington, and I was like, this guy's pretty cool, And then I started streaming, and then I started seeing all the others. But yeah, they've talked about it. I don't know. But do you want more competition in this space? What's that framework going to be like? I think the thing is, Astro has a really sweet spot, and if they just stay there, they're probably going to do very well for the next 5 years. Enough that they are very viable. If they try and overextend in these kind of ways and do stuff, they're going to get in the slog against React that they probably don't want to be in. Right now, they can just be like, look, you can use React here, and people can be like, okay, yay, we love Astro. Is there a theoretical feature where the state graph can be defined as which nodes on the? I don't think so. I don't like. How do you make that choice except for some kind of heuristic based on like what, right? Like the update cycle, but like I don't think you can automate this without AI or without like some kind of statistical analysis. It's not like you just work through the problem yourself, and then just think of like every exception case and how you can't make a general assumption there. No, and I said that in my talk. Honestly, I don't talk about the Rails and the HTMXs and Laravel or whatever, because from my perspective, they're just not even on the map. Like, like it's not because like, I might be critical of stuff like Quick and all this stuff. It just, I just don't even, they're just like, not even like the one thing that could change that is if if like stateful servers come back and then the interaction gets a little bit interesting, and we've been seeing people playing around with that. But otherwise, if we're talking about in the stateless world, JavaScript is the only option, not even close. Like profiler guided, yeah, like right, like so that's what I'm saying. You need like to run something. You need to actually do something. The analysis of like the structure of the code can't tell you this. You'd have to be like it's slow, or you'd have to be like users use this, or you'd have to be like you need some kind of input that is not the code itself. I don't. The question is, can like I don't know. You can't if you look at it this way, use server and use client might not even have to be a rule, but like you change the wording and then it becomes like an intention. You need the way to flag the intention. And we've gotten there with reactive languages because we've gone to a point where like there's state and there's derived state and there's effects. And we can understand the intention of those and the guarantees with them, and we built a language to it. If we can build a language to this, then yes. But the language initially might be like use server, use client. Do you understand what I'm saying? Like you need a way of describing the problem in such a way to actually do it, because just structurally, I don't think there's enough information there. You have to like say like this is high priority, this is low priority. You need like some kind of way of. So when I said impossible, I don't mean like in all futures impossible. I just mean the way people view the way they write their code today, not possible. We need a way of describing the intention in a way that is still permissive enough that the server, or sorry, the compiler, builder, analyzer can do something with it, but explicit enough that it actually knows what the hell we intend. Right? I don't think this is a structural solve kind of problem. So ultimately, soon client side running for sure due to state. Yes. Yeah. I mean, if you want one solution, if you don't care and you have multiple solutions, and you can be like, look, I have my marketing page app here, or sorry, site, and I have my interactive site here, then yeah, keep on doing what you're doing. But if you want to have a one single model, persistent state is a must. Big challenge, super challenge. Yeah. Yeah. Somehow we got completely off mark today on talking about compilers, but I'm glad you guys are like that. Right. Technically, we have RSCs and OCaml and Gleeman's. Okay. Yeah. I mean, I don't know enough about these other languages, but I have to imagine from a fundamentals point that there has to be a language that capture the intention. It's not enough to be purely structural to be able to make these kind of decisions. You have to have some kind of, yeah. Anyway, but I'm just speculating here. Keep in mind, like, I've never learned OCaml, so yeah, the Russian guy. He likes reminding everyone how he has the best reactive library framework or whatever. He probably does. I've been trying to follow his writing. There's tons of genius in it. I just can't get the whole conclusion. It's tricky. I think it's just a language barrier. But he does show up on my articles sometimes and on Twitter and responding to stuff. And usually everything he posts is pretty spot on. Okay. All right. I didn't realize people wanted to talk about compilers so much. I don't honestly just chose this cover, topic in general because it aligned a bit with what I've been doing in Solid. I've been working a lot on reactivity, signals 2.0, so to speak, async, and all that stuff. And I was like, this suspense topic seems like it's like right in the same ballpark, right? But I think we need a little bit of like, how should I put it? We need a little introduction, a little bit fundamental, so we're talking the same language before we actually pour into it. I just want to quickly see if there's anything. Why am I talking about DX here? Man, I'm so sick of syntax arguments on Twitter. I think I got on one the other day. It's like as bad as talking about Celsius versus Fahrenheit. Okay. So yeah, I was gone. There's a gap. Okay. Before we go, I want to say one last thing about benchmarking. Oh, Dan removed his post. No, Dan is gone? Is Dan gone? What's going on here? Dan. He should just be Dan, but there's a Dan 3. Oh, it's a parody account. Dan 2 is gone? Oh man. So there's nothing to show. This is too bad. Dan was comparing the JS framework benchmark to like putting a car up on those rollers where you don't actually connect it to a power source and you just run the engine as fast as it can to kind of test the characteristics of the engine. You guys are Dan is gone. Maybe permanently with the blue sky. Yeah. Oh well. And because he's basically saying, most code is app code and all this. And I talked about this a bit earlier, but because we talked about the compiler and we talked about this, I should take care of this right now before we get too off track. I took a little different. A benchmark is like taking a car to the racetrack and seeing which is the fastest. But if in reality you're just driving around town, what does it matter? Because the DOM is the load. You know what I mean? Right? Like the DOM is the thing that's is the load. It's the road. And I said I still want to build the fastest, most efficient car. We know you like to. Okay, where is this? Loose on the weekend, but blah blah blah. I'm just talking car ads. The glue is disproportionately measured in benchmarks. It stress tests at weights that exceed normal usage. It doesn't test every possible scenario or even realistic ones, but it tests all the basic functionalities in usable UI. It drives. Ultimately, we know every driver app code is different. The driver is more impactful than the car, and when you move between cars, that part is going to stay the same. But what sort of car do you want to drive? Yeah. See, what I was trying to say is like saying that the app code is the most expensive assumes that like it's like yes, but then shouldn't every framework have the same app code in these examples, right? I guess the difference between render models between React or Solid or something like that would make the app code run differently, but I don't see that as something working negatively, on to our disadvantage here. So I think it's still important to stress test the car itself without a driver, so to speak. Anyway, just a small tangent. I guess the bigger learning here is that Dan is no longer on Twitter. So yeah. Okay. Let's move on. You're saying the same things. Yeah. Yeah. Mostly. I just think like he was saying that almost that like the it wasn't real because there was no load on it. And I'm an electronics guy, right? Like it's like when you test something without hooking up to a speaker, there's no sync, there's no whatever. I don't think the benchmark is that there's no sync. It's more of like, there's a huge sync. It's like putting the car on like a track with a ton of resistance. Do you know what I mean? Like it's, yeah, I don't know. Maybe it's a subtle difference. Yeah, yeah. Yeah, I know. He's just that's why there's a Dan too. Now there's no more. There's no more Dan. Oh, what? That's surprising. Sorry, I thought I was already following Coding Garden. You guys should too. It's the random things I notice. Anyway, we're going to talk about syntax more later, but I want to get into the meat of the discussion today. So let's get it somewhere else. Let's go Excalidraw maybe. Yeah. Let's find some space. That seems like some space. I see. Yeah. Okay. That's fair. Yeah. Yeah. How much of that is of or the most efficient car? Yeah. How much of that is like a personality thing? Like, yeah, Dan definitely doesn't drive a Lambo. Could you guys guess what I drive? Not a Lambo. But there is a weird personality alignment on this. Honda. Not close, not quite. It's actually not. I drove Japanese cars most of my life, but I now have an American car. But actually, it's German technically. I drive a Ford Focus RS. Before that, I drove an Evo Lancer, or I never owned a Subaru STI, but that's where I am, right? I actually did drive a Volkswagen Jetta for a while, but I think you guys get what I'm saying, right? Cars that look basically like a consumer compact car, but have the you know the best technology, all wheel drive, good horsepower, yeah, you know, that kind of thing, yeah, I loved my yeah. Honestly, that Evo was unreal. There you go. Sure. Okay, it's time. But yeah. So, but yeah, not a Lambo guy, not a Porsche guy, not even like a Boss Mustang kind of guy. I like cars that I like, and my RS, I guess, has a tiny bit of a wing on it, but like I don't need a huge wing. I'd rather the car look clean but have a lot under the hood. I love GTR. GTR is yeah. If I had a lot of money, yeah, yeah, yeah. Yeah. Right. Here you go. Does that say anything about Leptos? I don't know. No, I love GTR is so cool, and not. I mean, the are obviously the R35 generation or whatever. But I still have a very big soft spot for like the R34 and the R32. Um, anyway, all right. Sorry, this went again on a tangent. I did own, because of my love of GTRs. I did own uh an Infinity G35 for a while. Um, and it was the nicest car I'd ever owned to that point. It had like nice seats and nice heating and a nice sound system. Uh, right, because that's technically what do they call those? Like they're called the Skyline GT350 in in Japan or whatnot. It's Nissan Skyline GT350. But yeah, I don't know. Anyways, car conversation is a little bit off point. Let me see if I can get a playground up going too from what I want to do here. No, you can tell the last demo I did. Whenever I'm showing this is my like World Beyond Components talk. But I'm like, look at how you don't need a compiler. Let's reset that. Need Ricer.js. Oh man. Okay. I don't know the best way to do this, but I wanted to do some sort of coloring because I feel like one of the differences before we even get into suspense for a moment, but I want to like show something here, which is that like I'm going to do my classic example. And we're gonna do one more. We're gonna do a create effect. Actually, yeah, we're gonna do a create effect, and the create effect is going to show double count. It's funny. I wanted to start with React, and we will go there in a second. And the create effect is going to console.log count. Okay. Everyone can see this, right? So what I'm trying to do here is I don't actually care what this is very much. I just want to kind of show a cycle. Let's actually change this to React code. I wonder if I paste stuff in. Yeah, this is not going to work. I almost have to like take a screenshot and draw over it. It's probably going to be our best bet. Yeah, okay, that's fine. Because I actually don't care if this app actually works or not. I just need to. Let's make a React version of this. Use state. Use memo. Count times 2. Count. Use effect. Yeah, count. Change text alignment. Yeah, but I don't even get like syntax highlighting or whatever. And what I want here is there we go. Just gonna do that just so I can see. What I really want to do here is just like turn off the bell. Actually, let's align this so that executable parts run on different lines. So it'll be useful. Yeah. Okay. There we go. Okay. Now I have no clue if what I'm trying to do here is going to make any sense or if it's even a good thing to do, but we're going to try and do this right now because we have some React code. And if we insert an image, I'm like dumb. I'm trying to remember, where did my screenshots last up? Put them somewhere. I can't remember where I put them on this computer. Found it. Let's just drop it right here. Okay. Let's look at this statement by statement, but we're going to do a little coloring here. I'm going to define some swatches here for color code sake, but we're going to say that I'm going to make this solid. I'm going to say that this is pure. And then this is render. And then this is post render. Okay. I want to talk about scheduling essentially, is what I'm doing right here. Okay. Everyone following so far? Yeah, I did read his articles translated to English, and I still don't quite follow him 100% of the time. Okay, so if this is React, and we're just going to kind of scribble along the side here, we're going to start with pure, right? When we run our code, this runs during the pure phase. This whole thing runs during the pure phase. This count runs during the pure phase. And then this JSX all runs during the pure phase. This is what it looks like in React, okay? Right? And if I switch now to red, or sorry, I'm going to switch to blue now. The only other thing that we have here is this, which runs post render. So what I'm trying to show here is that there is no render kind of exposed to you as a React developer. Pretty much the whole component runs pure, except it schedules the use effect to run post render. More people should like the stream. Is this where I remind people to like and subscribe because it makes a big difference? Right. The truth of the matter is, outside of this, React, will do something like have, like, you could picture your components being called, during it's unfortunate they call it the render phase, but you'd be like, run components, and then there's patch and diff, right? Or diff and patch, sorry. Diff and patch. That happens outside this happens outside here, and in this phase, this is green and this is red. So essentially, at all times with React, when the code you write as an end user is either going to be pure code or it's going to be scheduled post render. The actual rendering or effectful part of the stuff of the framework is actually completely hidden from you at all times. And it's important to note that even part of this use effect is run during the pure phase. They know that this use effect is related to count, that they can choose whether to schedule it or not, right? Okay. So then, all right, let's get out of here. So let's take our solid example and do the same exercising as this, right? And I'm going to talk about solid today first, and then we can talk about what some of the other frameworks are doing, right? I actually don't need to switch this to a new line because there's no dependency array. This one I do, whatever. I'll just do it for fun. Okay. All right, let's do this. Actually, I want to add one more thing to this example. Do I? No, not yet. We'll get there. Okay. Someone was asking if the Mac just copied it, but no. I mean, let's move this over. Actually, no. I'll first paste our image in. Okay. I'm gonna just because so I can get it all on the screen. I'm going to just copy it over like this. Okay. And then this is solid today. Let's just say solid. Okay. No, it doesn't run all pure. Let me get here. I mean, I think there's something we have to look at here, because if we're talking about the initial render, then yeah, this runs pure. This runs pure. And this runs pure as well. Okay. And then obviously this runs post render initially. And I want you to note something. Nothing about the effect, including knowing the dependency of count, runs pure. So we don't actually know what the effect depends on at the time, because you run pure then render then post render, like. And then solid, when it updates, is a little bit more interesting because React, regardless of whether it updates or, sorry, just gonna like move these around so they're a little bit more grouped together. React, regardless of whether it's first render or updates, it looks the same. Whereas like in a fine grained render like solid, what ends up happening is none of the stuff outside runs again, obviously, because we don't re-render components. So when something updates, focusing just on the expressions, this runs pure. This runs after. And this renders render. Now, and you might be going, okay, because essentially our render effects render during the pure phase during our initial renders. We run them eagerly the same way create memo runs eagerly in solid. And then after the fact, they get scheduled like this. Okay. right? And the reason I'm highlighting that is because it's literally just this expression, right? We don't recreate the rest of the stuff. No, 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 no. Memos and effects are very, 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 very different. I use that as a basic example so people understand reactivity, but um, memos are the key to, like, the derivation and stuff is the key to everything. Let me drop an article in. I guess this is like should be like the next reading for anyone who reads my introduction series. Maybe I should tag this one on as like part 3. Of the I have the but derivations and reactivity is important. The reason I wanted to show this is because I'm gonna make one more example here. I'm gonna add like a in front of the effect. I'm gonna hoist out a function. I'm gonna call it const triple count, and I'm just gonna make it a function, not a memo. Okay, and it's gonna be count times 3. Okay. The reason I want to do this I'm going to show you in a minute. Oh, did I not? Duh. Sorry, I need to do one more screenshot. I didn't actually update this to use triple count. Oh, that's annoying. It's fine. It auto formatted on me. It's fine. Auto formatting is a good thing. I just was trying to do something very specific. All right, let's try this again. The reason I wanted to include the function here, because I want to make this at least aware, even with Solid today or whatnot, is that doing our same exercise again on update, pure, red, blue, right? What colors this triple count function? I find it funny in virtualization in games similar beats all competitors in terms of speed. Yeah, I mean, if you cheat the benchmark, then you cheat the benchmark. Every framework can add virtualization. The point isn't to to reduce the DOM work; it's to show the overhead of the framework doing the same DOM work. So, like, this is kind of part of the problem with benchmarks in general. Like, everybody can virtualize. Everyone can, yeah. So how's the guessing going? Green, blue, green, blue, green, blue, none, red, green. Okay, you guys, purple. Ooh, no. The answer is blue, and the reason the answer is blue is because it's just a function. You called it at the time you're running this, so it is just blue. There's nothing fancy about it. But what it does mean is there is definitely a difference scheduling wise between using a memo and not using a memo, right? If I did the same thing in React, again, I mean, it's unsurprising that if I put it in effect, that it would just call the function at that point. But I just want to. This is a bigger difference from a reactivity standpoint. Um, as I said, this is just an aside. I just want you to think about this in general, about the meaning of, when something is part of the different parts of the graph, right? The thing is, in React, actually, you know what? The React example wouldn't be that. The React example, you would have to depend on triple count. Sorry, yeah, I'm wrong. Sorry. And it would depend on triple count, which means that it would be green in React because you would have to get that dependency to feed into the use effect. So it would be green in React. Yeah, that was actually my whole point I was trying to make. Sorry, I got lost there. Right? In React, it's green. In Solid, this is an inconsistency. You're beating me to it, Craig. Yeah. If you use both effects, then it'd be purple. Yeah. No, yeah, React would be green, is what I'm getting at. Because for it to be a dependency of use effect here, you'd have to execute it out here. Like it would have to be executed during the pure phase, and then the effect would do that. So React is all green except for just this thing in here. And what I was trying to get at is technically Solid, these binding, like the red here isn't, like during initial render, I'm kind of lying because the technically the expression runs during the green here and the creation of the elements, but the actual insertion happens in the like red zone, so to speak. We like memo up and then we unwind back into insert like render effects. So like technically there is like a little bit of green, like or red, like right there initially. But when it comes to updates, it's like the whole expression, right? So I'm trying to show actually the inconsistency between our model, right? Compared to React, which is always the same in terms of execution scheduling. Okay. I have the answer to Svelte. Yeah. I mean, Svelte, it's Svelte 5. It's going to be similar to what I'm going to about to show you, which is the next thing. Older Svelte is kind of like, I don't even really know. I think older Svelte was so simple that like they didn't even really take scheduling into consideration that much. Like everything would just kind of rerun, and then whatever the value was when it reran. Like old Svelte was kind of similar to React, so I wouldn't be surprised. And I like if it was all green, or like maybe like this. Old Svelte was more like React. Like there's no dependency array bit, but you know what I mean? Like they definitely didn't have this or this update model part. They were just like this more or less. They might not run all the code again, but like so like you could skip the state part, but all the expressions they would basically like check if they have to run them again. Be all blonde. Okay. So you're already starting to see the inconsistencies. And the reason I wanted to do that is because I wanted to go, this is what's solid today, right? That's what I was saying. Now, what if we look at the update? And I'm going to use this last example again because it's more interesting. So let's label some stuff. Yeah, so this one is solid update. And then we'll call this one solid update number 2. Okay. It's not even number 2. It's like solid update with function. Okay. Doesn't matter. Okay. So I'm going to take this example again and present like solid. The reason this works this way in solid is because we eagerly evaluate all our memos, not just initially, but after the fact. Like when we queue them, all our computed values onto a stack. So they always run before the effects, before the render effects, and we get that clear green that always happens. However, if you have a lazy system, right? If you have a lazy system, and so now we're going to call this one lazy signals. And if you want to know frameworks that have implemented lazy signals, it's basically everyone but who's not solid or SJS at this point. This has been the new trend when Preact added signals, Angular added signals, when Svelte adding signals. They all went lazy because lazy means that you don't have to do the work for the memo unless someone listens to it. Now, in a lot of apps, that doesn't actually matter very much. Like you wire the graph, but there are situations where that actually is a benefit. I just never cared about it very much. But the big win is that you don't have to run this, right? But if you naively take lazy signals on the update and you come back here, let's try color coding again, shall we? Let's get our pen. Well, we know that this is always going to be render. And we know that this is going to be blue, as will this always be blue. What color is this memo? Well, the answer is the memo is actually blue as well, because it's red for the first time. Actually, no. Actually, the memo isn't blue. Sorry, I got this wrong. You know what color the memo is? It's red. Yeah, it's just because that's when you called it. Okay. So this is a bit of a mind twist because from my perspective, I mean, you'll see what this has to do with suspense in a minute, but like, yeah, because it's lazy. When if you use lazy signals, you don't compute something till you need it. So, and what I'm getting at is a memo that is right next to it that is used in an effect will be blue. Um, Basically, the order of the execution of this stuff depends on where it's consumed. And more interestingly, is there's no like guarantees on execution. See, the funny thing about the thing about this model is if you did all the pure work and then we're like, hey, I don't want to continue. I'm waiting for something async. You could just stop and not run any of this blue or red stuff. And you wouldn't care. And if you went here, you know, like, yeah, you wouldn't run this function, but also you kind of get it. You're just calling this function. But when you got here, it's already too late to say stop. Don't run any of the red or blue stuff because it got run for the first time and it's red. Not the first time. The very first time it's green. But my point is when something changes, count changes or something, it's not going to run this until it turns red. Yeah, yeah. Triple factoring of the count would be blue. Yeah. You mean the other way? Yeah. If triple count was called down here, it would be red. Yeah, it'd be wherever. The function was just to show. I wanted to show the memo like behavior before we got into it, so you can understand how it translates, right? So this is the signals solution that everyone's been pushing, and it's not actually very good from a like it's too late. You're already in the queue, sitting there, running, you know, these effects. Okay. So, okay, I just wanted to kind of establish this. And the reason I want to establish this is because if we go back to the beginning, no matter what I do with React, it's always going to be pure except for this thing. It's very easy to run everything and then schedule this blue thing. React basically has this whole cycle kind of dialed in. Can we get that sort of predictability? Like Solid today is actually very close with fine-grained updates, very close to having that sort of predictability, but it's not perfect. Well, what if you did this? Now, I know you guys, no one likes this, but what if we did this? And what if the render effects also did this, essentially? Like, so basically, there was two halves. So, like, this double count was like this, right? Now, you're going to tell me that this looks a lot like React. I'm sure. But if you separate the two halves, let's run it. Let's separate the two halves. What do we got here? Well, we already know in all of these initially we're going to be doing a lot of green, right? But I'm going to run the initial run through. So we're going to call this one split initial. Okay. We're going to split initial here. What we're going to see is, yeah, obviously green, obviously, but not. This is still lazy. I should emphasize this because this is not the order. Sorry, let's actually do the order of how this. I mean, this could run eagerly, but it doesn't have to. It could call this eagerly, and then so it goes green. It could, yeah. I guess, yeah. This is eager. Otherwise, the graph can't be created. And then it gets the effect, and technically, this is deferred still. We'll get to that in a second, but it's still queued like the eager one is. So I'll get to that during the pure queue. So then we get here, and this is green. It reads the double count. Okay. And maybe we have those little red squigglies here, like I showed before. And then it reads this still during the pure phase, which means it reads this still during the pure phase. And then finally, we get our blue after we've rendered everything, right? So this looks similar to I never did this version of the diagram. I never did, like, for us, but if this had been, sorry, this version, I never did this initially, but if this is initially, this would have still been blue, even initially. So the difference between this and split initially is that it actually is the same as React's behavior. And after the fact, split update. Well, it knows the dependencies. So now you update count. Count actually queues up this first, which means this runs green and this runs green, which means this runs green. And sorry, I already missed this one. This one means this one runs green as well. And then this runs red. It does the insertion. It's like the code you don't see. and then this runs blue. And as I said, effectively, this was always like that. So we've basically, through this process, if you noticed, we're looking at the same picture between update and split. It's not quite the same. This one just does way less work on update than initially, but the scheduling guarantees are actually the same, and they're the same as React, right? If you pass signal directly to DOM parts and had is signal, then you don't need the split tracking from the effect. So you're saying if like only if it was compiler. The important part isn't the auto tracking. The important part is when the code actually runs from a scheduling thing. This has nothing to do with auto tracking, right? Like it's like unless the compiler was like looking for it, the important part is that the front bit, this expression runs separate from the thing that actually does the thing. This isn't about tracking. Yes, this is tracking scope, this is a non-tracking scope, but that doesn't you don't split it because of tracking. You split it because you want one to render one to execute during one point and the other stuff to execute afterwards. Here's the thing. Dependency can be dynamic. There is one difference between this and React. You can put conditionals in our expressions, right? This is not just a dependency array. Every time it runs, it can actually change what it depends on. So any static analysis, it's a problem that Svelte had, and even Marco, and why we went to runtime to a degree. Like compiler based is a good optimization, but it's not as dynamic. There's a reason why currently runtime based reactivity frameworks are faster than compiler based. It's because they technically the compiler should be faster, but the handling of dynamicism um, means that like whole categories of things over execute where they don't need to. This is not, again, this is one of those places where you don't know which path it's going to take ahead of time. It's kind of like the routing problem. To be sure, this is an R-change letter. No, the thing is, Solid, this is a reveal that Solid's design decisions, even though they weren't as clean, always were like React when it comes to the thoughts on scheduling, and why lazy is actually at odds with that thinking. The reason Solid has concurrent rendering, the reason Solid can do suspense and transitions decently was we ignored cases like this a little bit, like where the function, and we're like, and some loopholes around effects. Like if this was, but otherwise we're like 95% React when it came to scheduling standpoint. The difference between Solid and React is that the dependency, like, or not even Solid yet, but like this thing I'm talking about with the split is the dependencies can be dynamic. It's like you have one more dimension. It's like, I don't know, you guys know calculus? It's like React is this, like, gives you like this one view of how things work. Like I don't know, like how do I put this? Like it's like the relationship between velocity and acceleration, like we are one step back where like we can like signals are just like adding this, like, I don't know what to call it. You guys technical, it's like when you step through that kind of difference, like when you're going between like velocity and acceleration, like that kind of dimension. It's not a dimension though, like a spatial dimension. It's like we're basically approaching the problem by constructing React's scheduler dynamically at runtime. It's like that extra level degree of control. React is a project installed. Maybe that's it. Yeah. Yeah. What's gained from having single drivers around a consistent schedule? Yes. Thank you. Now, see, we're following. This is why I started here, right? I think React has the best one of the best approaches, thoughts to like async model, right? Right? Yeah. So like in a sense, what makes Solid feel so powerful compared to React is that we have the ability to like have that extra bit of control. React is like when you have the equations because you know that, how to calculate acceleration or velocity, but you don't have the means to show that they're a projection of the other one, that like it's just derived, not or a derivative of it, right? Like Solid gives you the control, like gives you the syntax, gives you the means to basically create that, derivation. So yeah, why am I getting here? And why do I care about scheduling? Well, it depends on how you want to handle concurrency, right? And how do you want to handle async? Because the reason for all of this stuff is kind of back down to an article I wrote a while ago. I'll share this one. I also have some new updated things, but it's like, what was this article? Why all the suspense? Yeah, this one. I'm gonna drop this one in here. Oh, weird. Sorry, that link won't work because it has instead of hitting the enter key, I hit the there's like an apostrophe or something at the end of it. Okay, let's try that again. I don't know that concurrent rendering has helped them a ton, honestly. But there's something nice about async models that makes sense. And if you start kind of thinking in this sort of derived calculus sort of kind of way, you start seeing, and like in terms of projections, you start seeing like signals are like almost something very similar to the React mentality, but expressed as primitives that have nothing like it separates like it gets rid of like the like a lot of the rendering aspects of it, like component view hierarchical thing. It's just the guarantees. And in a sense, if you could approach async as if signals were just like that system was just a projection of of the async model, then you could perhaps picture something where like all the pieces just fit seamlessly, because async is a hard topic, right? It's way easier to talk about consistency in user interfaces. This is where we always talk about stuff, where you update something, it doesn't reflect properly in the other side. And I talk a bit about this before, but what I wanted to get at is like this classic problem of like having something fundamentally derived async. Do you know what I mean? Like you have a count. Let's pretend that you needed to calculate the double count on the server, and then you update it. There's going to be that time period when you initially load it that the counts the initial value, and you have not calculated the the derived thing, and then it will come in, and then there's a point where you update it, and you'll see again the updated value with the old value until finally the new value comes in. And it's very easy to do this in any framework. You just use effect and feed it back into the state tree. But the question is, if you, what if you could treat async as if it's part of the graph, right? Like it's part of the derived graph, right? That's essentially the question here. Could we make other guarantees, right? The problem is that there's only really, you can't get the async stuff any sooner than you can get the async stuff, right? So there's only three options here when you're in one of these intermediate states. Bail out, as I call it, like hide what's going on, like put it behind a fallback. Basically, be like, I'm never going to show it when it's inconsistent. I'm just going to show, it when it settles. You could stay in the past. You can be like, I'm going to keep on showing the previous, like the 1 and 2, all the way until 20 and 40 both come. Or you can be like, do an approximation in the client. Let's say you knew that times 2 is such a bad example, but like if you could approximate it, maybe you can like show the thing before it actually loads, and then when it show the real thing when it comes in, right? Obviously, with times 2, it's pretty easy to approximate it. You just times it by 2. But these are basically the only three options you have for async. And this kind of brings us to our topic of suspense today, because suspense is involved in all of these. But the key part about it is that everyone associates it with is the bailout, right? But it's not the whole story. So yeah, I mean, I talked about this article a while ago, but yeah, don't worry. I'm gonna also grab some HackMDs while I'm at it, just because I haven't for a while. On the, just get myself ready here, because I think it's got it. It shows you how long I've been in here. Been here. Yeah, let's get this. Let me get my two-factor authentication going here. Sorry guys for the delay. All right. Eights. All right. All right. All right. Let's continue on. I think the first thing we have to kind of acknowledge in this conversation is frameworks don't need to handle this necessarily. There's always solutions outside of it, but it's pretty compelling to look at this from a first principle standpoint and then be like, how do I, implement this in a way that's like nice or logical for people to use, right? Because the benefit from a first principles standpoint is that, like, in theory, you can present a completely consistent, perfect model. In reality, that might fall apart a bit. GitHub forgot who I was. Yeah. Anyway, I'll get to my HackMDs as relevant when we get there. But the thing that it's funny because I didn't actually write about this part, and I probably should have. Let me see if I can. Is this the? No, it's not this one. Sorry, I just need to find the right one. Okay, this is the right one. Okay. I'm going to drop this in here for anyone who cares to read, but we'll talk a bit to this while we continue on here, okay? I'm trying to think of how I want to handle the next piece. Sorry, just give me 2 seconds as I kind of noodle on that. It's just we've kind of talked about, we've danced around pieces of this before on the stream. So I'm trying to decide like how basic or like how far back I want to pull this. Is like I think, and it's one of the challenges that we've faced recently, is like people don't know why suspense, or if they do implement suspense in a lot of frameworks, it's like not particularly interesting, right? Because hiding stuff until it's ready isn't that hard of a mechanism to make, right? You basically have some way of detecting the asyncness. In React, they throw promises, and other frameworks, they just like register that they got a promise, you know, like views setup function. And then, or like await components in like Svelte. And then when it finishes awaiting, promise then you show the while it's not, visible, you show like a fallback. And then when it's finished, you show the updated rendered thing. But this whole topic is a lot harder than just hiding stuff, because hiding stuff is pretty jarring, right? Like, let me go here. Go to the tutorial. Right. I mean, it's fine. Let me see if people are used to this, right? When you switch between pages, you see loading, you see loading, you see loading. But like, picture if it was something that you want to update that like wasn't so substantial, like you were flipping through like a cart of like the same type of things, like a bunch of, I don't know, maybe user profiles. You're going 1, 2, 3, like, depending on where this is, it's a lot to always just fall back to loading indicators like this. I think a lot of people would be fine with it, but the tricky part with a lot of these mechanisms are, the second you have something async in flight, it's game on, right? Like, you it has no choice but to, default to this kind of hiding loading indicator. And the truth of the matter is, I would argue that, and I did hear that all of these three options are equally viable, like things that you would be interested in potentially doing sometimes, right? Sure, you want to bail out on initial load, but once you've loaded some content, maybe you want to stay in the past and just apply the updates as they come in. You know, there's actually a fourth option that I don't actually have here, which is to not. Um, right. Sometimes you want to tear. Maybe you have a type ahead where you have an input and you want to be able to have the input update pretty quickly, but then the search results are async and they kind of come in, as waterfall. Right. These are these are situations where essentially, like, it's difficult to just have a single solution handle all these problems. And a lot of the design around things like suspense are trying to make it so that it is possible to opt in and opt out of these behaviors. Okay. So, like, the simplest example I can think of here was, I posted in this article, which is like, pretend you have two pieces of data that you show on the page, like a username and a street address. If you're able to edit either of these, independently, you wouldn't care. Like, if you had two inputs and two pieces of data, separate parts of the page, doesn't matter, and you were able to update one and have it update right away, independently of, somewhere else on the page updating, obviously you don't really care that these update independently. However, maybe if you had a process that involved, say, like a form where you updated both of them together, like this is a user and the street they live on, you might not expect these to update separately. Like, if you clicked save, you might expect the update for both of these to come in at the same time. Now, keep in mind, I'm talking about sync right now, no async, just like a simple example. So because it's sync, there's no delay anyway, so they would probably update at the same time. But, like, conceptually, I just want to kind of establish this idea that it's possible that, depending on the action you're taking, you might have different expectations on what updates come in together or not. Where we hit this in sync all the time is actually in the reactive graph, right? So, like, if there was cross dependencies downstream, you don't want to do independent calculations multiple times because you process things in the wrong order. It's the reason we have signals, right? It's to make sure that like if you know something like I don't know why, like if the way you displayed the name changed based on the person's address, you wouldn't want to like process the name first one way and then realize that the address is also changed and then have to process the name again. Sure, it's synchronous, so it's all going to kind of come up really quickly, but there is a cost of processing and you want to make sure that every node executes once, right? So there is a consideration even synchronously about things that are conceptually connected versus conceptually separate, right? Luckily for us on sync systems, it's not hard to solve because literally like that's why React exists, that's why Solid exists. We have these rendering libraries to make sure that they're, we're not going to get these weird mismatches where something, sees something that's out of date mixed with something that's updated, and then like either not get the final correct solution or run things more times than they need to. Right. So the funny thing though is if I took that same example and brought it back into async, where we have these two pieces of data, pretend for the sake of this, and I'm just using my article here as kind of the basis here. Pretend that we had a stylized showing of like the person's username. Maybe we like made a graphic for their the first letter of their name that was like in some special stylized text, right? So whenever we change their name, we actually have to go generate an image that so we can show it, right? So again, if the address and the name have nothing to do with each other conceptually from a UI process standpoint, how like maybe it's not the user's address, maybe it's a different address over here and a user thing over here. I don't know why your UI would be like that, but I'm just saying then you'd have no problem with these things updating separately, right? But we do have to consider, the case, I guess even before we consider the case of like them together, we have to consider the case of if I update the name, say it starts as John and changes to Jacob. See, those both start with J, so maybe stylized. Let's pretend just a stylized version of their name as an image. When we go and click save, we could show Jacob immediately, right? Because we know they've changed to Jacob. But there's no way we will have that stylized image for Jacob right away, right? So, this is where our options are. Show Jacob's name immediately while still showing John's image until the new one comes in. Show John in both places until the image for Jacob comes in. Show some kind of like loading placeholder for the image and show Jacob's name right away. And then when it comes in, show the image for Jacob, or approximate it, which is kind of like optimistic update. Show Jacob's text and then don't show an image, but where the image is, maybe show like text of Jacob that's sort of in the same style, but not fully rendered. But you can kind of see that there is really 4 options here. Yeah, I mean that's why not show the old image with a loading indicator? That's hold. That's option 2, right? I'm not saying you don't necessarily need an affordance, but I mean, why not actually showing that loading indicator may or may not be difficult. I'll get to that in a second, but that is a variation on hold essentially, right? Like you show both John until then the image comes in. I guess or are you talking about tearing? Show the old image with a loading indicator. Yeah, I guess the other one is I guess I see what you're saying. You're saying show Jacob, but then show the old image with the loading indicators. I would consider that then that's not hold. That's essentially placeholder or approximate. It's 3 or 4. Yeah, show the old titanium. Yeah, so that's basically 3 or 4 because you're not. I guess you're tearing. Yeah, so you're saying tearing plus an additional loading indicator. Okay, maybe that is just one. Yeah. Yeah. I'm gonna consider that one. That one's not bad. There's a lot of places. That's a perfect example of where you might say tearing is acceptable, right? Right. Like places that I sometimes with a loading affordance, tearing is fine. Places that are really awkward for tearing are like, let's see if I can find it. Movies app. What was it? Taste movies app. Um, I can't even. Or is it Taste.js? Was that it? This demo, the Angular. Of course, it's down. Well, that was short lived. Sorry, I had this in my pocket as my example of tearing, and but I haven't been here for a while. None of the other frameworks actually tear in here, I don't think. Um, but the Angular. Okay, there it is. See, when I change the categories here, I go from action. This is an example of tearing, right? I go to adventure. It's going to show adventure, and then it's going to load the data. Comedy. It's funny because it's already been preloaded, so I'm not going to see it. Let's go to history, right? Yeah, I mean that's the thing. There isn't actually a problem with any of these. Is what I'm getting at. You might actually want them for different types of situations, right? You might say tearing is fine. You might say I want to hold, right? Um, I love hold with loading indicator. It's one of my favorite ones. Like yeah, like I wonder if I can actually see holding with a loading indicator in here. I think Nux does it too. If I go to here, no. Hmm. Trying to see if I don't think anyone actually no the other demos don't do the category thing the same way. That's hold with the loading indicator, I think. Do you see that? Yeah. See, that's holding with the loading indicator. As soon as I click on it, the loading indicator goes, and then it comes in, right? You notice how there's no loading on the actual thing, right? And it holds on the current page. Yeah. Yeah, that's a good example. Um yeah. Yeah, oh yeah. Holding by itself is completely unresponsive. Yeah, yeah. Yeah, yeah. Yeah, yeah. You want it holding needs to have a loading affordance. Okay. Let's keep on going. See, this example shows holding with an affordance of fading out the current text while it's waiting. It's still on the same page, but then it fades out the current text while it's holding. If it's too slow, if it's fast, it does it fast. But if it's slow, you'll see you'll see it fade out the text while it holds. Anyways, yeah. Um. So where was I going? Oh yeah, but yeah, what I was trying to say is there isn't a clear answer for every situation. Like if there's a lot of input changing often quickly, you might want to tear like a live search box. If you're coordinating many parts of large portions of the UI, you probably want to hold. Dropping to placeholders when you've already have content is jarring, and having things flying over the place is disorienting. Placeholders are great, when it's like initial load, when you were like switching to something and you're like context switching, or it's going to take a long time. And then approximating isn't always possible. It's good for mutations, like optimistic mutations, but you can't always do it, right? So it's kind of like this interesting question, right? Because where I'm getting at is most synchronous frameworks provide synchronous guarantees, but then the second you go in async, you tear. And trying to actually make things behave in a different manner is actually hard. If you're tear by default, the way to implement holding is challenging, right? Placeholders is not too bad. We talked about that, right? But like you could see this even in a situation like our movies app, but like our image example is good too, right? Because like if we are changing the state, like I mean, you can. I don't know if I should just draw this in Excalidraw or like if we need a visual aid for this, but like if you had text John, right, and then you had I don't know over here John, we'll call this our image. I'll make it red. I don't really care, and um actually this isn't good to see visually. I'm it's actually easier to see with code, like because you're like, how do you get this to hold for you in this scenario? Because I mean, let's see if I actually put code in here. Yeah. I'm just going to make up some syntax here. You guys don't have to worry about it too much. But yeah, I think I'm done with this. Okay. Pretend this is you rendering these things together. And then you have a signal, some state for the name, some state for the address, and some state that asyncly generates the image URL where you're going to load the image from based on that name. Okay. Right. How would you hold in this situation? Because if someone goes set name to Jacob, right? The second you do that, well, what ends up happening. You end up running this effect with the updated name. The name URL has not had a chance to thing, so it returns probably the previous value. Like, how do you hold name so that it doesn't get up? Because you need name to trigger to generate the new image. But like you need name. Like, what if I have a second effect over here that's just create effect console.log name? How could I ever stop this from running? Do I even want to? Like, if I actually update name, it needs to know to run these things. It has to run this, right? It doesn't have to run this. It has to run this. It has to run this to even know that it can generate the next image. But if it's run that, like, is it too late? Like, the reason, because this effect has nothing to do with this effect. Right? Like, it's fine. Losing some viewers here. It's fine. But like, just think about, you have to update something to trigger something, but that trigger is going to affect other things. Now, you could say don't run any of the effects as a way of holding, but how do you show the loading indicator if you don't run any effects? Right, but I mean, we can make excuses for ourselves, but these are also trivial examples. I'm picturing examples where this is non-trivial, right? like there is something very awkward here, right? Like we can obviously like use suspense and be like, don't show it out of state. So update the name right away. This is tearing. But trying to actually implement holding, do you know what the answer is? This is how you implement holding. Essentially. I'm going to assume that this is fixed, right? I think, is this right? Yeah. This is how you do it, right? And then you set name to Jacob, and then maybe, I mean, let's do this. I'm trying to think of like, I'm just making this up right now because it's like I'm picturing what the system would be like. But you'd almost have to be like, whenever name image URL changes, set display name to name or something like, but you maybe like untrack name or something. Okay. Like this is essentially what you'd have to do if you wanted to implement holding, right? You'd essentially have to create a second signal to show that and have that one update independently of the one that triggers the fork of the stuff, and then when it finishes, then update the state that you're displaying to match it, right? But I mean, it's not even enough to do that. Like, do you understand? Like, this is such a simple case because it's flat and you know exactly. But every possible signal or derivation along that path is going to basically, you're going to have to make your own copy of it. I guess it's source state. So it's all the source states that could be impacted along the line into async data would have to be copied. Yeah. And people do this all the time, to be fair. I mean, I would like to compute it, but it's hard. It needs to synchronize with this, right? Which is what the only reason I used an effect. Like technically, yeah, okay. Yeah. Can we write this as a memo? Um it's like maybe something like this would work, and then make this const display name. Yeah, I like that better. And then we just have to set the initial value to John or something like that. Something like this. And then this actually has to get hoisted above here so the reference works. Okay, slightly better. Same problem though. Some parts of the app might want the held version, some might want the fresh data. Yeah, yeah, but like this is like literally dealing with one async thing. Picture if you had multiple async things. Picture if they were hierarchical, how much forking of state you would have to do. I mean, you could do nested create effect, sure, but like what I'm kind of like, does that simplify writing the logic at all here? Maybe, but it doesn't remove the need for the state, I don't think. And like some things are nested. Sometimes they're two different places in the display. Like this is my fictional create render effect of you displaying something on the screen, right? Like these are I use console logs here, but like these are basically render effects. Streams and RxJS solve this. Not, I mean, but you still in the end have to deal with the synchronization of state, which RxJS does not solve. It's right? Like it's good at handling transforms, but like at a certain point, you're if you want to, like, I just wanted to kind of put it out there. What if you actually tried to get this holding behavior yourself? This is the most basic way of doing it, right? If I didn't use create async, it actually might even be easier. Like that's why derivations look good. But if we use create effect, we could also like if we were using create effect to generate our image, we could set both signals at the same time, right? If we weren't using derivation, like we could be like generate image URL, get image URL, and then go set image that set display name that. That's generally how you do it. You you I generally don't recommend doing writes inside something that is quote pure, but if you were using effects to do the fetching, you would just have two signals that you'd set. Right, and choose a name. But I'm saying this is like the simplest case, right? So to speak. And I what I was trying to suggest is what if what I started with just worked that way, right? Without you having to manually duplicate the state, right? Like this is like one piece of state that you'd have to duplicate. What if there was dozens? Like keeping display versions of everything. Like this is like a mechanical problem. Like this is not your intention being displayed on the app. This is like mechanically solving for stuff using signals as counters to keep track of references. Like that level of solution. What's great about signals and stuff is that creating these kind of solutions is easier to do because it doesn't tap into the React render cycle, which is incredibly inefficient if you're just doing all these crazy little state writes. But it's not the ideal place you want to be. Ideally, you want to just be like, look, here's my data that's derived from this, and this is what I want to display consistently, right? Create transaction. Yeah, we're getting there. Yeah. Um, yeah. So what do I have here? Return our example, which is already displaying the name John and an image of it. If we independently update the name or address, it would be fine for those changes to come in independently, yes. But we'd expect the case of the name to show John until we can display Jacob. You know, if we're trying to hold, we can do that. We can show an affordance for loading, which we talked about. If we change the name and change the address, we accept that the address change appeared before the name change if they did not feel connected processes. Yeah, no more than a ticking clock. Yeah, because I mean, I think you start seeing the problem here is because if you actually had to block all the effects, like my previous example. Yeah, okay, sorry, I've jumped around a bit. I'll help clarify. This is how you would manually implement it, right? What I originally wrote, um, yeah, okay. Sorry, I'm just going to continue here. All I was trying to suggest is that in this part here is that if the address was related to the name and you click save at the same time, you might expect them all to come in at the same time again. I was trying to basically my assumption here is it's the process that defines the dependence between things, not necessarily the dependency graph or yeah, not necessarily the dependency graph because obviously like if you have multiple effects, obviously a single effect that's showing something inconsistent can't be allowed to show it. But if for any group of changes that you expect to come together, if any of the effects show, you're going to potentially have tearing, which is what I was showing before. And if you didn't want tearing, then that grouping isn't enough to only look at the dependencies or which effects put stuff together. You basically would have to look at every downstream change from that single update process. I would be okay having to read a signal in an effect scope just to tell it to need to wait for it rather than duplicating states. Yeah. But it's not, you understand, it's not without duplication. How do you show something and be calculating the next thing at the same time? Right? I mean, that's kind of what the problem is, right? Because if you don't, yeah. Right, because consider yeah, sorry, this is what I was trying to show this example. Consider if these 2 things are independent, like the name and the address had nothing to do with each other with this code example, okay? Now, if someone set name, we're back to only having a single thing. If someone set name and it's off, generating the name, and then someone sets address, if these were 2 separate things, you'd be fine having the console log kinda go like this, like, John with the updated address, still showing John's current user URL. And then when Jacob comes in, show Jacob new address and Jacob's URL. So you still kind of want the address to update, even though you're waiting on the name, right? And even though they're in the same effect, like you might want that to happen. Conceptually, I'm hoping people are following. I understand this is like complicated. I'm just trying to suggest that the grouping of effects might happen automatically because of where something is in the JSX or some kind of other consequence. But things that update together separately might not at all be related to how you actually want to display or do side effects on them. And if we simply just block all the effects to get our holding, then nothing updates, right? Obviously, if it's in the same effect, it's obvious that it doesn't update, but nothing updates if we block all effects. Yeah, I mean, I keep on going on here. I don't know how deep I want to get into this, but like I start talking about hierarchical because we've established that dependencies aren't sufficient. It's process. I was thinking like, what about children? Like tab A and tab B, right? It's you have the same problem again. You're showing tab A, you click on tab B, you got to still show tab A while B's loading if you want to, hold. And the problem is if there's something updating on tab A, you can't just unmount it. Even if you can't shut it off in even in memory. Do you know what I mean? Like if you've ever seen something like Solid's create memo or something, if you create something nested, like a nested effect, the second that the outer effect runs, the internal effect is going to get thrown away. Maybe you haven't rendered the new thing in the DOM yet, but you've released the memory because now you're taking the other branch, you're taking the other condition. And but in this world where we're trying to hold, it's quite possible that things need to still update even though they're below the point at which we've forked. Trying to do that manually this way is basically impossible. It's not, you have to hoist all the state data up to where the decision point is, like where the route is, where the tab switch is, in order to do it. You maybe use context or something. But the problem is the second you like it the second you switch to the new page, you have to not any decision, like you have to not release the current page. It's not enough just not to show it, but you actually have to not release it, which means that it can't be running the same code path. Every control flow fork decision has to keep both copies of it if you want it to stay live. Right? Like, I'm trying to think of how to show this, but like create memo. Simplest version. Count bigger or tab equals A otherwise B, okay? Simple as I can, we can make this example. When tab changes between A and B, like you could say visible tab, we could play that game, but you need to duplicate all the logic because what if the fetching happens or the async thing happens below the fold, right? You have to hoist it up, I guess, is the other possibility, because it's not going to run tab B until you change this. And the second you change this, you are releasing tab A, right? Because when you rerun the memo, this gets garbage collected, right? Yes. This is where I'm trying to get at here. So because we always talk about suspense, but it's important to understand that suspense is only one of the three modes. Suspense impacts the other stuff with the transitions, but I think it's important to understand that like trying to you basically have two options. You either hoist all the state up, like when you have to deal with it hierarchically, or you come up with a means where every decision point's aware of the fact that it can hold both decisions. This is kind of beyond what I think, between duplicating states and stuff that end users can do. You can build your architecture that way, definitely, but you start seeing that, like, if you've ever been down this road, I mean, I think you just give up on holding being an option, generally speaking. Right. You accept a certain amount of tearing. And maybe that is the wise thing to do. But like it is not easy to avoid to do holding without having a framework known mechanism in place. Okay. Right. So all I'm trying to get to with this part of the discussion here is that like this is why there are transitions or transactions or whatever in in the suspense frameworks, is because once you commit to being consistent, while suspense is a great tool to hide stuff, it's too jarring. Most people want suspense initially so that they can like show some placeholders, but they don't want it to keep on triggering over and over again when stuff changes. But if you want to keep that consistency, you're going to either have to have controlled tearing or you're going to have to hold. And holding is very hard to do hierarchically, which is a large part of the design decisions behind suspense. Okay. Anyways, let's continue here. Okay. Let's see, where did I end on this? Yeah, I was just saying, yeah. I think my last point was I don't even know. Is there any interest in this part of the topic? It's just that this is a big ask. I'm recognizing for people because my last real this understanding with this model kind of came in is that if transactions are essential as a way of doing it, it's awkward that you'd have to wrap every setter with a transaction if you didn't want it to fall back. If you didn't want it, if you wanted, so like could is there a way we could have implicit transactions? But because of the way that I was telling you everything's tied to process, it's hard to actually have implicit transaction. It's kind of like a decision you make by the actions that you do in your application, right? Whether things are connected together or not defines whether it's would need a transaction or a transition. It's not the grouping of effects that decides that or the dependency graph. It's actually the processes you do in your app. So yeah, sorry. I just want to read my conclusion. It's nearly impossible to automate transactional boundaries. There's tension between responsiveness, especially of inputs, and this desires to have everything apply at once. Yeah, that's the other thing. If there's times you need tearing, so you want to be able to to not freeze your input because it has some async dependency downstream. What things go together goes beyond dependencies and probably needs to be explicit. Concurrency seems unavoidable. It would be great to keep things simple, but tearing is difficult to avoid and blocking is untenable in many situations because both of those facts, it seems like we're stuck on explicit transaction model if we want to have tools in this area. Okay. That was my conclusion here. And that's essentially like where like React sits, right? How I got here from when I was talking about scheduling is that in order to do transactions, you need to be able to pause stuff or basically run the pure part of calculations multiple times without doing any side effects, right? If you've got to be able to like test it, you got to be able to run the data, hit the async, pause it, and be able to resolve all that stuff without the side effects impacting. And you can't do that if your rendering is all freaking weaved together, happening at sorry, that's a good example, but like happening at random times in the cycle. You get this far and go, oh crap, that's where my async dependency is. Like you don't get to do that if the first time you understand that you need something async is when you're already in the effects queue. Right. Yeah. I mean, I guess this is part of the challenge here because people, I get this over and over again. People don't know how to use suspense or transactions. So when we like go to build stuff, everyone's like, oh, I would just do it this way. But like, there's, you can accomplish, well, this is what this next article is. Well, not a real life example, but I have better examples here. I was trying to get the heavy theoretical stuff here because I was like, okay, what if we tried to just do the different models ourselves? I showed you how hard it is to do holding when you're in a current framework with that tears generally. But what if we started the other way? What if we started where holding was the default behavior when you hit async? And how would you make it do all three things? Placeholder, tear, whatever. So that's here. So let's start with something simple. You get a post based on like I don't know the route ID, and then you have a nav that shows the selected post, and then you show the post title and the post body. Now, if you notice one little detail, there's no null check on the post here because I'm assuming a holding model. So with a holding model, it's possible to basically when we get here and when we get here to just pause it. You get here and we can throw. I don't mean throw the component. This is solid. It's fine grained. We'll just throw this one little binding, and we'll just throw this one little binding, and then when this finishes, we'll finish our rendering. Okay. So that's the thing here. Basically, non-nullable async data because of being able to hold. Essentially, you never have to check if the data is there. It will always be there, right? This is what I've been talking about a lot the last like in my Signals 2.0 stream. I mean, my hack MDs, I'm hoping eventually have the right content. I don't think this stuff is digestible by people. Otherwise, I'd be publishing this stuff on Dev2 or whatever. I think I think it still needs more explanation. For me to get this to a Dev2 article would take me about a week's worth of work per. I think both of these might be my sequel to derivations and reactivity article. I just don't have time right now, and I know it's funny. I'm not wasting, but like spending time explaining this to people on stream. This also helps me talk it through. I feel like the first time you write something, you have an idea. The second time when you try and teach someone, you learn the second stage. So you guys participating in chat is really great. Yes. I don't like the term transition. It's overloaded. So when I talk about React, I'll call them transitions, and we have them solved today. But I'm generalizing it as transactions as a term. But like, let's pretend this is what you could do. You could literally just write some async data, and it be non-nullable because you know that it will just block fine-grained where you need it. Okay. Now, if we were consistent by default upon running this page, we'd show nothing until the posts are available. If you think about it, if we were like truly consistent as our default, we'd have a blank screen until the posts loaded because we wouldn't run any of the effects, right? And this is kind of consistent with how React Server Components handle when you have no suspense on the server. It just waits until you render everything, and then it ships all the HTML, right? This is one of the challenges I actually had. Side note with Solid was that our client model is tear by default, and so it's very difficult for us to like change our server model to be hold by default. But I kind of like that about how React Server Components actually hold, our SSR now kind of holds by default. Just as a side note, but essentially, if this was a client app, I'm not talking about SSR right now. If this is a client app, you'd literally render nothing until the data loaded. Now we could obviously show the nav earlier than that, and the loading state. So that's what suspense is for, right? So you just go in here and go, okay, I'm going to wrap this with suspense, and now I can show the nav the second I load the page, show the loading post, and then when the data comes in, it comes in, right? This is what suspense is for, right? So I'm just saying, if we had a fictional framework where no suspense meant we don't render anything until async resolved, this is kind of what my mental experiment is, right? I think this would be confusing as hell because people would come and render stuff and they'd add something async, and then like everything would hold up on them, and they'd be just like, what the is going on here? But if you could change the norm of expectation, like this would be this is what this mental exercise is. Yeah, no, I see the argument for this. I don't know what that demo or example would be, to be fair. I haven't built a real world app in about 4 or 5 years, which sounds terrible, but it's true. I spent the first 20 years of my career building apps or websites of dynamic nature. I'll call them apps, but then the last 5 years I haven't done almost zero. So it's like yeah. Yes, exactly. This is what I'm saying in terms of yeah. Yeah. The funniest thing is like, yeah, the challenge with that is, I honestly think for me to switch around to get into that mode, it would take me a couple weeks of effort. To like find the right example and then actually try and build it out. I remember I was making the real world demo, which isn't even real world, um, and a while ago with Solid, and I like using that. But even that's a big demo. I like using different demos as a way of testing those kind of ideas. But like, yeah, no, it's interesting. I suspect that I won't. I just literally don't have the time to do it. But yeah, it's interesting. Unless like it was a real long draw. Like I spent like I did it during my stream time, and I did it over the course of like a couple months, like piece by piece. Because like it's funny. Like when I'm working on solid, like I just got a solid release out today, and I've been working on it the last 2 days. I have a hard time even being able to like switch context and work on a specific library in the solid ecosystem, or solid start or whatever, and then like go to the next one, because like if I drop anything too long, the bugs start stacking up, and unhappy developers wanting help and whatever, different situations. So it's like it's very difficult to actually not just be jumping from specific narrow focus thing to specific narrow focus thing. Like the reason I'm in here is I'm literally working on Solid 2.0 reactive system, right? Whereas like, yeah, I almost, yeah, all my work is like in these very focused little chunks. I am kind of hoping it help. I sometimes go on other people's streams and do stuff where they're building something real, and maybe then I can help them or something like that. It's very hard for me to have like something that I actually want to build to actually do, unless it's like again a technical demo, and then it's very small, right? Like yeah. I'm not familiar with that issue. Submit a bug if there's a bug. I 1.8 is a really recent release. 1.8's been out for like 6 months. I'm not familiar with this. I guess so, but I mean, on the other hand, yeah, I mean, it's pretty challenging to like to find time to do things more ambitious than like a hacker news or that kind of stuff. Uh, yeah, it's easy. I'd rather help someone build a real project than that they want and are able to do. The challenge, obviously, with that is um, a lot of those are private, and then the results don't get shared anywhere. I don't know. I mean, it's interesting. I'm not sure if the stream is perfect for it. Would people want to see? I mean, it might be worth putting up the poll sometime. People want to see like several. Like the problem is, I actually use a stream for me too. Like that's like lost time. I mean, it's probably fine, but like, would people want to see an ongoing project over several weeks being built? Okay. Anyway, getting back to where I was going here. If we were consistent by default, rendering page would not show anything. Okay. So where I was getting at here is you show suspense, it does what you want, right? Via placeholder. The other way to show nav right away would be opting into tearing. Okay. And the way you'd opt into tearing, I don't have an exact syntax, but you've used this in create resource .latest or whatever. If you could basically put latest on it, then it should be possible to opt into tearing, because then it's not going to trigger suspense, presumably, and then you should be able to just get the latest value. But you notice that these null checks now are here, because technically to get the latest value includes undefined, I think, which means that there is a period where it's not available, and you'd be just showing empty H1s and Ps. But to be fair, I doubt anyone would try and show an empty header when they're waiting for the data. If they wanted to opt into tearing, I mean, obviously, you can set default value on our create async, and then you don't have to null check. But I think more than likely, what you would do is you'd actually show a placeholder anyways, right? So it's not even real tearing. You could just go show latest post, and then use the type narrowed version of this, and we're kind of back in business. But the thing I want to note here is the similarity between show when latest post, fallback, this type narrowed, and our suspense version. Our suspense version, basically the same structure, just way cleaner, and you didn't have to worry about the null checking and all that in this future framework, kind of zone that I'm talking about. Also, side note, I think I am probably the worst person to actually do this. I think there's people on the Solid team who have done like way better sites and work on this, especially people in the DX team, people who build the Solid Docs team. They're actually all better equipped to actually show something, I truthfully. People who are good at making videos, I'm not one of those. Solid 2 win. Well, we're getting there. Okay. So let's talk about this a little bit more. So okay. So this is just initial render and showing how you could do tearing, how you could do a placeholder, how you could maybe this would like what holding could look like, right? How about taking our same example and updating, right? Well, if it was a purely consistent model, then when we update, change the route, go to post ID 2, we just wouldn't show the nav. Everything would basically, all the effects would basically be held. And then once the async finished, it would go and then it would update the nav, whatever the nav is, and then it show the data, right? Each of H1P would be notified the post possible change, and they would hold effects until the post is available. This would mean that nav would not be able to render. Basically, it's almost like you have like an invisible suspense wrapping your whole app, I think, if you went like a consistent first kind of scenario. It's not quite the same as suspense, but essentially something collecting and holding the effects. Again, if we had suspense, as we change the ID, we just unmount, render the new things. The funny thing is with suspense here is it doesn't even necessarily render new things. It just detaches these nodes, and then when the text changes, it reattaches the nodes. The way, like, we don't actually do re-rendering in suspense on the client. Like it's actually, in this case, I think it would actually just right. And then our tearing solution would actually show the updated ID right away, and then it would show the old stuff until the new stuff loaded, right? So you wouldn't really like, obviously what I was trying to get with the tearing example is if you wanted a placeholder, you'd probably just use suspense and not bother with this. Where is it? I'm trying to find it. Show component that I showed here. Like, you wouldn't bother with this. If you actually wanted tearing, you would do this, and then it would just do its thing. I think latest as an API is awkward. This is a whole other tangent, but I think there's some challenges there. I don't think you guys care about those challenges just yet. If you're really interested, you can read the article. Let's continue, though. It was just kind of noting that in general, it's important to note in this example that if we had a downstream component that we were rendering here, like let's say this was a post page, and then we rendered a post component in here, they wouldn't expect post to ever be null, right? You could basically build components that are synchronously expecting that the post data was there, right? Like post accepts post. And then if it was, where is it? Sorry, I scrolled too far. If you read the async thing directly, since it's non-nullable, there'd be a guarantee that post would be there. Or if you grab the latest using some latest API, it could be null, which means that you have to actually give it a default value. It's kind of an interesting kind of thought that it might be possible with, to have TypeScript help you in these situations where basically people can author simple components that aren't aware of async, that are non-nullable, and then at the point of passing them props, you can still pass them that something that will resolve, like this, async resource, something that is non-nullable because of the blocking nature of the system, or be able to grab the latest value, and because of it being nullable, force it to default. And like if you just tried to pass post.latest to it, or latest wrap post, I haven't decided on the API on it or whatever, then because it could be null, you get a TypeScript error. Anyway. Yeah, I mean, the way solid start works right now is you have to put a suspense boundary in above the highest async. So everything in the outside the suspense boundary flushes immediately synchronously. If suspense boundary suspends, then we send that on the next stream thing, and hierarchically any suspense boundary below will just either come in together or as its data resolves. But our main mode right now, for solid start and all solid rendering generally, is that outside the first suspense boundary has to be synchronous, and we'll send that response pretty much right away, unless while rendering into the suspense boundary, we hit resources that are like defer the stream, and then we'll wait from sending the stream until those ones have resolved. Because we, even when we walk into suspense boundary, it's still like we do the whole first pass synchronously. So we do walk in and find everything as far as we can. So we do know if we hit resources that need to be deferred and that need to hold the stream. It's just our default. We need suspense in order to do that the way we are today. Not really, because post.latest or post, you almost kind of do it the other way around. Because if you, I guess you could, yeah, fair enough, you can. That way, that would be how you would do something that suspends only the first time, right? Because you would essentially read the latest, it'd be undefined, then you would read from post, which would suspend, and then the next time around when it updates, post.latest will have a value, and then it won't read post and it won't suspend. So yeah, that would be the trick if you wanted to have something that would suspend the first time and then basically um, tear after the fact. That's probably a really good pattern for a lot of people, actually, now that you mention it. Well, because if you, the solid today is as if, almost as if latest was the default. It's not quite true, which I'll get to a bit later here, but it's we have to null check everything because we don't block even fine grained. Like if you hit like post dot title and post is null, like that's going to throw, it's going to error because post isn't there the way solid is today. We don't have like a throwing suspense mechanism. So generally, you're going to have to provide initial value when you intend to use latest, because, or someone has to provide an initial value along the lines, because that latest value before any data has ever been resolved is going to be undefined, right? There's the time to get the first data, right? Whereas if you have a blocking system, like I'm talking about with createAsync here, where you're not opting out into the latest, because the way it runs, that it will always have a value. But it's it's one way or the other, right? Either you wait for there to be a value and it's blocking, or you grab the latest and it's not blocking, but it's possibly undefined. This or statement is clever because it's essentially saying, if there's a value, go with that. Otherwise, wait for it. I was assuming this post was calling post as a function. Maybe that's a wrong assumption. Yeah, and solid start does. We assume that you need suspense for async, which is one of the hardest, which is where this conversation kind of comes in, because it's hard not to have the framework needs to know to wait, right? If we go render and we don't hit any suspense and we hit and you call some prompts, like how do we know to wait? Now we could wait on every resource, every async call that you make on the server to finish before we send any response back. But like how would we possibly stream that? Like we need a way of knowing what's ready, what things depend on. And as I said, I do like how React with RSCs have changed the default to like hold, but like classically with SSR, you try and render synchronously and then like the client picks up the slack. So you need mechanisms to be able to tell the server to wait. Suspense is that mechanism. I think if you unified the consistency first model, you could argue you wouldn't need suspense, but we're not there, right? Because when we added this stuff to solid, it was opt-in. Like you can use create resource without suspense in solid, right? You can just like go and use it to load async data. And the way we opted into like a tearing model by default because that's how all reactivity works. It wasn't like it didn't like if you have an effect that writes the state, that's basically how all async is worked. So I didn't think much of it. But now in hindsight, I kind of realized that like there might be better defaults, right? And that's really what this conversation's about. Right. And yeah, I mean, I think one of the hardest parts here is I have no idea. The problem with all these examples is we're kind of okay if it holds the world, we're just like we're looking at this and we're like, okay, well, I mean that's not the example, but it doesn't matter. Like we're kind of okay that okay, this doesn't update, this doesn't update, this doesn't update. But the problem is with holding the world is without transactions, like I was talking about before, without transitions or something, nothing is responsive while it's holding the world. You need to be able to fork it if you're going to take that hold the world positioning as your default, because otherwise you hit something async and now nothing is responsive. And I think the problem is today in React and Solid, you need to wrap your stuff in a start transition. I have an example here and here, but you go use transition and then you call start around your setter, and that tells us that these things need to update together. That this is a process. It's a fine API, and the key part is it actually gives you back a signal where that you can use as a loading state. And we built this into stuff like our router. So when you go is routing, it will give you a signal, and you can actually show that hey, it is routing. You can keep the stuff on the page, and then here's a fade. You can do that some kind of other sign, but you can hold while showing something's going on. You can't show a loading indicator if you lock the whole screen. That's why you need transitions or transactions if you have a holding model. But if everything's holding by default, I think it's confusing. People wouldn't expect the second they add async that the whole app freezes, right? It was what Benton said earlier, where he's like, holding is great as long as you show it, right? Otherwise, it feels like it freezes up. So if your default is holding everything, and then someone adds something async, and then they're like, why is my app so slow? It's going to reflect poorly. One way you can get around that is make transactions implicit. So, you don't kill the stuff running on the page while something else unrelated updates. But the challenge with that, as we already talked about, is it's not clear what things are grouped together. And if you just treated everything as a separate transaction, which is fine, there's no clear way of getting the pending state in. Right here, it's very obvious. You have like this return pending that you can use for your transaction. But here, it's like, what does every state setter have the ability to check if it's pending? Right? Because it's not about the read; it's about the write. Right? Latest is great because it like latest doesn't get you the next value. Latest gets you the past value. Do you know what I mean? Like if you look at all these examples where I'm talking about the latest post, it's not, maybe latest is a poor name for it. It's after we've changed to the next ID. We've gone from 1 to 2. Latest actually means get 1. Ignore that 2 is in flight. So latest is actually not like it gives you a way to read the past. There's no way to opt into reading the future, right? And that's I think it's important to understand on a transactional side. It's kind of intentional because those whole branches just need to live in the future, and the other branches need to stay in the past. You don't want that sort of tearing, but you need a way for the branches that are in the past to know that, hey, there's something happening in the future. And I have no clue of what kind of API surface we'd need for that. Explicit transactions are very nice because they let us group things together the way we want to, and they give us a clear API fixture, right? You can't just like have set count return a signal, because then it's like you don't get a chance to insert it into the graph, Like you could call set count in 10 different places, like in an event handler. You can't there's no you're not going to like assign a variable that you pre-declared, at the top of your file component, top of your component that only runs once, and then have that somehow insert into the renderer, like that we're not re-rendering. Like you basically have to have the marker for whether something is listening to be pending to happen ahead of time. It would be no different in React either, right? Because the events happen outside of the render model. Like where you actually do the set count happens outside. So you need to actually have the fixture to track the transition already existing at render time. So like, yeah, the APIs here get kind of challenging. I still understand forking. If you hold, how's that different from just deferring the state update until the async tasks are complete? Well, what I'm talking about forking is if both sides could exist at the same time, right? You're right. The naive, like simple approach is like when you get to go from A or B and you have that, switch happening here between these tabs, you release A and render B, and then A is basically dead. But what if instead of doing that, you had a different copy of this memo essentially? So this one doesn't rerun, it stays on A, and you have a different copy that evaluates now to B. So both of them are live at the same time. And then you can like realize that these are connected in different time, and then eventually stitch them back together. We have a version of this in Solid right now. But you have to basically fork the reactive graph. Is the thing, because really, as I've already kind of shown here with the manual approach, you need to have different copies of the signal or different way of reading the signal that reads different values in order to make this work. And in general, I mean, it's true with React too. Like they have hooks where they persist state. You have to have a different version of that state on the concurrent branch for it to work and read from. Why create async as of today is not often using mutate method like create resource? Mostly because directionality and single source of truth. It's hard to extend that writability piece. Like if you want to have like create async store or something like that. It's the reason why create resource doesn't have has a weird experimental thing trying to get stores to work. It's because trying to write to a store is different than writing to a signal. So it's almost better. Not almost. I think it's better to treat async as derived value and then have a way to write over it, right? Like project it temporary. So we had an idea in Solid I've showed before called createWritable, which is a writable memo. It's still fine for directionality. The biggest problem is like when you have like an effect right to a signal, you're like restarting the update loop again. When you have like basically you can't have any guarantees because you can't backtrace through the right. Like if you have a signal and you're like, if you have signal A and B and you have an effect that writes to B, depends on A. B doesn't know that A is its dependency because you've decoupled it, because essentially the effect listens to A and then it writes to B, but B doesn't know that it kind of depends on the effect, which depends on A. You've broken that linkage. Whereas, like, if you used create memo and you directly see that B depends on A, and we can make sure not to execute things, unnecessarily. And I think that if you treat async like that, you have the same kind of benefit of directionality in the graph, and it's fine to derive something that also can be overridden because you still keep the directionality of deriving. So like I've shown this before. I don't have an example with it right now, but like createWritable could basically be used as a way of it would have like createWritable has a signature like this. Create. So let's pretend it's like count, set count. I know this is terrible. It's in all my examples, but if you had createWritable, then it could sync with like say props.count, but also overwrite that value. And because of the directionality, you know that it depends on props.count, even though it can be temporarily overridden. If props.count ever updates, it will overwrite the value that you've set in count. But at least you keep this directionality, right? Which is very different than if you have a situation where you have this. Because with this, you don't actually know that count depends on props.count. Like this is just the value. I mean, this could even be null because the first time it runs it. I mean, effects run later. I mean, you start getting into a place where you're like doing value writes during rendering, and it's just a nasty place you don't want to be with. By changing everything to being derived, it cleans everything up. And similarly, my thinking is that why not just put the async thing in here? So you create something async and then have essentially a writable projection on top. This way you keep the source of truth. When the async data updates, it refreshes the your writable temporary version, and you update this as you wish, and then you push the changes back to the server. Async pulls through, and you get the loop, and you keep the directionality. Anyways, sorry, a little bit of tangent. I hope that kind of makes sense. It's just createWritable made create async less extension. Or sorry, not createWritable. Sorry, having mutate on create resource made it less extensible because you'd have to preserve that the right side as well, and they could have different rules. Anyway, yeah, I mean, but the thing is, as long as those see, we had this lovely thing in our systems where we execute everything synchronously. So like we are fine to have these. Yeah, you could say that the state tier, but like they can't see each other. They live in their own bubble of world, and by the time they reconcile and everything comes together, that they will be consistent. Yeah, I mean, in a sense, but what I'm getting at is if you actually don't want to tear hierarchically, you can hoist, but it becomes like the more complex the situation comes in terms of structural considerations, the harder it becomes, like I demonstrated earlier, right? Like um like the display name versus name, I mean that one's simple, but like right. So, where am I going here? Not that. This. So yeah, React has this position that new suspense boundaries created under a transition don't get added to the transaction and instead go to fallback. But this, doesn't help with things already on the page. They need to stay in the past. The typehead problem. Yeah. So you kind of, as I said, you kind of end up in this situation where, like, if you go implicit transaction, even if we solve the API, you'd still need a way to be like, no, I want this not to update, you know, transactionally, like not be held up by async. I want this just to tear on its own. I don't know. I kind of got that far in this thinking, and then I got here and I was like, well, what about inconsistency first? Right? Let's go back to where, like now that I've gone way down this deep end, let's go back to how frameworks are today. Right? Right? What are the options? We lock up all effects like proposed, basically treating the top level app as if it were a suspense of sorts. This aligns with idealized server rendering, probably. We do inconsistent tearing based on how effects are grouped. We expect people to use the tools provided to get the experience they want. Or we default to .latest instead of throwing, but we're back to null checks. But tearing happens predictably. But yeah, there's basically, we have three options here, right? I guess to be fair, there might be a third option, which is like not even trigger suspense unless you like if you default to latest, that suggests not triggering suspense. So like right now solid actually triggers suspense, but I think the problem is, so instead of latest you'd want to have wait, and if you set wait it would throw and then resume when it came back. To be fair, like I was saying, like what if you like swapped it around so it's latest by default, but then if you wanted to wait you would wrap it. But what I realized is that wrapping something like to say hey throw is the same as doing a null check. Like it's basically pointless to have an implicit wait. So like from an yeah, here was my conclusions. We maybe eliminated some options, but unless we want to give up colorless async, like the null checking ability, you have to go by throwing by default, right? Because basically throwing by not throwing by default, throwing by opt-in makes no sense. Which means that top level will never tear predictably. What I mean by that is if you have a system that throws, you're going to at least have effects that share the same dependencies, which means it's possible to have like name update one place, but name grouped with async thing not updated in a different place, right? The one benefit of the current systems is that they tear, even though they tear predictably. Like name will be updated everywhere, and but so like this is kind of like the crux of the problem. So we really have to think hard whether we want to freeze, like as I said, like make sure everything's consistent before we show anything by default above suspense, or accept that top level there is inconsistent tearing. Freezing top level is a lot nicer if we have implicit transactions, as consistency first wouldn't have to block the universe. However, without an API to track the state of the particular transaction, it's pretty difficult. The linking has to be on the right side, and we can't just inject signals into the graph. They need to already be there before. This could be an option worth exploring, but it seems awkward. So if we aren't implicitly transacting, how do we feel about freezing top level? Most people should be using the tools like suspense, but if they don't, they'll find themselves unexpectedly waiting for stuff. They'll think their app is slow. To be fair, this only happens if they opt in to create async. If they just use effects, they will still just, everything will work as it does today. We see this all the time with the router when people don't realize there's a transaction under the hood. I don't think it's intuitive at the moment. However, having unpredictable tearing due to effect grouping is hardly better. I can see people trying to work around either behavior. At least with freezing, they have control by using latest. I see this on the router all the time where people start using .latest to cheat out a suspense. With arbitrary tearing, they would probably need to just move stuff into different components for no real explainable reason other than, hey, you should use suspense. If all roads lead to the same place and freezing is more instructional, maybe it's better choice, or maybe I should spend some time thinking about implicit transactions. In either case, it does feel like pieces of solutions are aligning, and by that I mean like if you make certain decisions, they lead to other decisions. Like there's clearly like the paths aren't like a bunch of combinatorics. There's like one path or the other path. So basically, either we leave things relatively solid 1.0 style and null check, or we have to go pretty deep along the rabbit hole. That's that's kind of where my thinking went through. So I was talking to some people in the Discord after this, and I realized that like it's it is interesting that if you avoid certain primitives, you can basically avoid this whole thing altogether. If you just like use effects to do data loading, then you never have to worry about this, even with all these models in place. But it's like it's not going to, if you want it to be a consistent story with like SSR and like the whole pieces to work together, you almost have to like go all in, which is um challenging, right? Because it's like I don't know if I don't know if people in the ecosystem are ready for this. Like in a sense, this is the problem React has been facing because React might academically have worked it out. Like was this whole exercise with the Scala draw where I showed that React had basically figured out how to make a consistent async model, and I've basically figured out how to do the same fine grained in a reactive system. But it's like it's a big ask when people are like, I'm just building my site, I don't understand any of this. Like, think about how much language and how much um, misunderstanding goes into this stuff. I'm happy with the null check, yeah. But it's like, because of React, people aren't happy with the null check. It's the first thing I get every freaking time. It's weird to have a suspense component and a show component. You're like, what am I doing? Right? And the second you get rid of the null check, stuff starts looking so, I mean, I've showed it in some of these examples I'm showing. Like, this is way nicer, or where's the suspense version? This is way nicer than what most frameworks and tools get to do today. The fact that you can just like write that and just be like, look, SSR, everything taken care of. I don't even have to think about it. Async will just work exactly, the plan. Like we were getting the error. Okay. Well, it's more that there's ways that we can enforce this stuff like more strictly. Like there's ways that we can just like make rules that will make people very miserable, but will remove the foot guns because there is a consistent model here. You just have to be aware of it. Like one example is don't let people write during the pure phase. They can't write, like can't set state, can't set signals, can't do that during the pure phase. And if you look at my diagram here, you know, here, the pure phase is basically every freaking thing that they touch except for here. So you're allowed to call set state here and you're allowed to call it inside your event handlers. You can't call set state anywhere else, right? And if we literally errored in that scenario, there's a whole bunch of people who would be like throwing up their arms and couldn't figure out how to do stuff and be very confused and get very upset. But it wouldn't be there wouldn't be a foot gun. It just wouldn't work. Well, the problem is, I'm saying it doesn't fork by default. You have to opt in with a transaction. The problem is that the biggest challenge with suspense is that once you're in a suspense zone, there's only two ways out. There's dot latest, or so make sure that it only suspends initially. So like opt into tearing, or and maybe like that's such a common option that people should just use that all the time. Or using transactions, which require people to wrap their actions in their setters. And I don't think they're thinking that way. If I'm just creating some random app, am I going to do that? I think because otherwise the default suspense behavior has you dropping back to fallbacks really awkwardly. Like maybe if that part could be addressed in a consistent way, then the rest of this falls together, right? But the problem right now is you set some state, it triggers something async, you've just kind of blown up the world. It doesn't actually blow up, in Solid's case because we don't like re-render, but it unmounts it. So it's like really freaking awkward, like the way that it like kind of pops in and out on you. So like, yeah, I imagine that like I imagine that like that's the catch. I think that's ultimately going to be the catch. It's around this the fact that like there there isn't really much in between. And maybe it's just a matter of setting the right defaults. That's why I'm doing this exploration, because like the latest challenge is because yeah, I mean, the latest or post, as we saw before, actually keeps things non-null, right? Yeah, that's interesting. I think that's worth thinking through. Okay, that is an interesting thought, but I yes and yes to a certain degree, but like sometimes that's the best place for things to go. Otherwise, you duplicate your whole view tree logic outside in like a separate state container. And maybe you're fine with that, like old MVC. But like there's a reason we got away from that model. I think there is a certain amount of overlap. I think we have to recognize that these aren't like they aren't one to one. I think like if you think all state belongs in the component, you're wrong. But on the other hand, if you think all state belongs out, you're going to get a lot of duplication. Right. Nested suspense close pause with their async. Yeah, I mean that's generally it as well. I think I believe that if this model is adopted, it will be beautiful. But I think it's really hard to get people to actually adopt these kind of things. Well, it's not about the async logic. It's about getting the async in. And this is going to be really relevant when we talk about what happened with React 19 in a few minutes. Um, yeah, but I mean, suspense has this weird inversion of control where like it just goes up to the boundary that's where it jerks. And the reason you do that is because you want to be able to like not have a billion spinners and just have one. So like yeah, maybe we should fundamentally look at the nature of that. See, for me, a lot of this stuff, and sorry, let me just get this here. Um, 1 second. I want to grab an example here. One more example. Where is it? 2 seconds. Too much chat in the Discord before I got here. All right. The the reason that I'm getting to this point is because even before hitting suspense, you start thinking about the power of these async primitives, right? And I'm not going to say this is optimal from a performance standpoint, but I have implemented the non-blocking or the blocking async or like the fine grained blocking async, right? For example, count and then picture create async where it depends on count, and then it I'm just returning it after 400 milliseconds, and then there's a double count, which is a memo that depends on data.count. Notice no null check here, right? Even though data is async and it's an object, no null check here times 2. And then I created an effect on count, and then I created an effect. This is with the split effect, right? Which has a count and double count, and then I console log that. And then I set an interval where I update the count from 1 to 10 at a very fast pace. It's so fast that it interrupts the async from running because this takes 400 milliseconds. So this is already to 2 to 3 to 4 even before this finishes resolving. So what you actually end up seeing here is this first effect that's tied to count just go 1 2 3 4 5 6 7 8 9 10, and then the async log happen at the end with the final value. So this is an example of what I call unpredictable tearing, where it's partial, it's based on the effect grouping. This is like the easiest thing to do in the world. Like it's already set up this way, but you see it goes 1, 2, 3, 4, 5, 6, 7, 10, and then the last one comes in afterwards. Now, if I made this interval slower than the fetch, you'll see that each fetch comes in, as it goes, right? Do 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 do. But yeah, well, I mean, but you still have this complexity outside when you have you still have the complexity outside when you have like multiple things that depend on that. Like I guess because I think in signals, you could pull the whole signal graph out of your UI and still have to answer this question, like should count update in this scenario when there's somewhere else that, show that, shows count with double count. What if without a vector memo? Yeah, okay. Yeah, sorry. So do you want me to just go like this? Okay, I'm going to do the effect first. Without the memo, the same thing happens. The reason I wanted to show the memo for you guys is to understand that it's actually transient, which was not the case in Solid 1.0, that it actually propagates the async through here. Like if I go back to like obviously this is the same thing. Like the async actually propagates through the memo, which is something that we don't have today, which is freaking cool. But yes, you want to know what happens if I do this? Let's do this. Yeah, there we go. It throws because it throws here. But you have to remember that yeah, it throws. But like what I'm getting at is you have to remember when you're doing initial render that you're part of a pure render phase. So if it throws, right, coming back to here inside a component, wherever this demo is, if I just access it at top level for some weird reason and it throws here, technically speaking, it's part of the memo above it that will do it. I don't recommend accessing async data top level in your components. It's as bad as it's basically like putting an async await. You end up with a React model. Basically, yeah, people shouldn't do that. That's an interesting question. Oh no, I mean the function's fine. Sorry, the function's fine. Sorry, I missed the function wrapper. I meant top level in the component. If I just put this, if I got rid of the memo here and just went double count, that's fine too. I think the most interesting thing about this is if you try and read something, like in an event, right? This is why suspense is probably important, or not probably, it's definitely important, because if you have an event on your DOM that is reading this data, you probably want, you can obviously put latest around it, but you more than likely you want that whole section to be under suspense boundary, because if you, I mean, what is a scenario where you've not loaded the data, but you can run effects like run events against it? I'm not sure. I think you should be grouping these things together based on like whether they've loaded or not. Like people shouldn't be clicking buttons for something that hasn't loaded yet. But yes, it throws. I mean, what do you do? Like rerun the event later? Like like then you lose the synchronous time of the event. I mean, more than likely, the button click is going to either be disabled until the thing loads, or it's going to be part of the suspense boundary. Like I don't think it makes sense to build something where you're trying to interact with something that hasn't loaded yet. I don't know. Maybe that's a hole in this. It's a question. I did think about this though. You can also use latest to get to get out of the throwing, so to speak. I'm also talking about loading. You can also ask if it's loading. The loading and latest are like the two helpers that are really important here. But in any case, just kind of wanted to show that like it's kind of cool. I mean, I'm trying to think of like a scenario here that really show this in action. But like you could pretend like, I don't know, you could pretend like forget about this for a second. I mean, what could we do that was fun? We could make like a counter component, and then like const. What are we going to do? Make a div equals document dot create element, and then return div, and then create an effect. It's like document, or no, actually just div dot text. Actually, let's make it an H1. I mean, you guys have all seen my old solid demos, right? I guess this is a render effect. I guess to be fair, I could actually just do it right here. Just go. And then let's get rid of this. Let's create. Yeah, I'm just trying to think of like, yeah, let's just move this in here for now. I'm trying to think of ways to like show format. Document dot body append counter. What am I doing funny here? It's funny because HMR is not going to work properly the way this is. This is kind of what I want to do. Set count +1. Button dot text. content equals click. Yeah, I mean, this one's just holding, but like it's, I mean, if I really wanted to get fancy here, I could probably hoist the I could probably do something like display. See, right now I don't have the like a transaction, so there's no loading indicator. I can separate the effects to get that effect, but it's not real. What do I want to do? I want to move the H1 into. Do I ever want to move the H1 into here? I'm just trying to picture a scenario where, like, essentially you could have a dumb component that renders an H1, you know, and props.count, props.double count, let's say. Right. And then have essentially, would I call it display? Count, turn, count, get double count, return double count. And I'm basically just hand compiling this. And then H1 here. And then what I could do is yeah, let's pull async right out of the puzzle here. Right? I could author my component here. It's funny. Why does it? Oh, that's actually funny. I wonder why it's not showing the count initially. That might be a bug on my side. I wonder what this is. Interesting. Okay, so there's still some work to be done here, but what if I change this to 1? Okay, something is not happening as I'm expecting it to, but in any case, we see this updating initially. We created a component that essentially has no clue about async. It just takes 2 props in, right? And expects those props to always be defined. And then essentially we can add async into the tree here. And then like, what am I doing wrong here? Data. And then like, yeah, anyway, this is still very much a work in progress. But I just kind of like the thinking that's going into that. Yeah. Yes, this is equivalent to having async without colored functions. Yes, that's what I'm trying to show here. Right? But does it work? No, so far. Don't get me started on that. But yes, this is the idea here. I am comparing it to coloration of async because the point here is that we were able to build a component that was just able to render, and then we were able to add async capabilities above it without impacting its functionality, without having to go back into it. If you use latest, I don't know if I haven't exposed latest yet. This is very new, but yeah, I just this kind of playing around here, right? But yeah, this is essentially where the thinking's going. To be able to support these models, you need to have consistent scheduling, as I was trying to show before, and to do that, you need to actually separate the dependencies so that they can run in the pure part and only effects on the side part. And yeah, as I said, I don't. It's hard to tell how worth it all these things are, but seeing stuff come together like this, it feels incredibly powerful. So yeah, I'm. This is going to take a little time to rough out the edges, but like this is like as I'm trying to say is I think it's like React's model without a lot of the trade-offs of the React model because it's not blocking like we don't have like the reason this example works is because like if I had suspense, which I don't have, it's actually this read that is triggering the throw. It only throws right here because this is a getter, which then tries to read the memo, which tries to read the async. So if you put suspense here, like obviously you'd probably in a situation like this put suspense around this whole section. But my point is like the throw is pushed all the way down, which is the opposite where React, the throw happens right here. You generally will be like, where you introduce the async data into the component is where the throw happens. Which and don't get me wrong, they could try and push it down, but if they pushed it down, you have to rewrite display. There's a logical place to introduce it. You want to introduce it. I'm not saying you have to fetch. Like I'm fetching in here. You can hoist the fetching up, but I'm saying is you have to introduce it at the level you tend to want to introduce it at the level where you're aware of like suspense to a certain degree. But I mean, it could still be a level in between these two. But the important part is we can push the read all the way down to the leaves without rewriting the leaves. Yeah, I mean, it's fine. You just don't do get. Make this count. Make this double count. And then call this as a function. And then call this as a function. Yeah, the getters aren't important. Same thing. I'm just pointing out that like would the old current API still work for 2.0? I mean, from this perspective, create resource is just adding a bunch of stuff on top of create async, right? The tricky part is the implied behavior changes that would come with this in the way async's happening. It's syntactically it's not a problem. We could port old primitives across, but I think this change might be significant enough that I don't know if old code would run optimally. I mean, it's fine. I guess you just have extra null checks. I don't know. I haven't figured that out. If if we'd force it into a weird place where you'd have to null check still. Yeah. Is failing render silently better than getting an error about accessing blah and undefined? Is it gonna fail to render silently though? Like like if it throws, you're gonna catch it in an error boundary. If it's delayed, it's not that it's gonna fail to render, it's going to slow down silently. Like you're not gonna understand that why when I click this, it took a second. Suddenly somebody entered its async, you're like, why isn't this snappy anymore? That's the biggest fear here. And the solution to that is what I'm dwelling on a lot, because obviously if we change um if we can separate the processes in terms of like transactions or transitions, you won't be as impacted by it. But that's the challenge in this kind of async model. um Consistency is guaranteed, not speed, right? Elaborate a bit more on nested objects. I'm not quite following. Are you, like, generally speaking, like React or whatever, or like most of these kind of most signals things, like the entry point is here. So like nested reactivity it doesn't apply to async in the same way. It's almost impossible because like usually there's a source of the async. It's ultimately the reactive systems themselves, as they propagate data, only really understand synchronous things. All the async here is doing is breaking up that synchronous things into patches. So like there's no such thing as nested async, so to speak, I don't think. um you'd have to be able to convert it back out into something that you can read anyway. But yeah, I mean, this is very rough example. People, as I said, the code's not finished. People want to play with it. Maybe I can share this right here. Let me share that. You catch errors in the error boundary. It's where the read is. So we don't, you don't, it'll be the error boundary close to where, like, it's the same thing with our resources. When a resource errors, it's not like this component errors. It's wherever the this is read errors, the next closest error boundary is what clicks, which might end up with multiple error boundaries showing up at the same time. But it also makes sense because it's like this part of the UI couldn't render, couldn't update. Here's that. Now, the key part you have to understand is this propagation from create memo. It means now that because we can pass it through, error boundaries are only tied to effects. Like if a memo errors, it's only going to matter if an effect reads from it, including a render effect. So like all propagation is based on effects, and the effects create the hierarchy of the render tree. So like unlike solid today, we actually get a very clear separation, which is I'm pretty stoked about, because it's there are clearly two graphs. I'm so confused with the two callback. You shouldn't set signals in the first one, but what else is decided for what goes where? Yeah, basically the first one tracks in the this will help you a bit. This side tracks, this side does not track. So if everything reactive should be here. The part that gets weird, and this is the part that I came to realize over time, is creation isn't a side effect. So when we render like child components under conditional, it all happens on this side. This is like where you finally insert it into the DOM. So like nested effects go in this side. Nested everything goes in this side. You shouldn't be creating reactivity on this side. Um, and this is what I'm getting at, is it's why it's sort of like that React projection thing I was talking about. You want the creation all to happen on the pure side, all the creation. And even our nesting, is on the pure side, right? Like I'm saying components are like nesting. So like, yeah, it took me a moment to realize that, but then I got it. So yeah, the effect will catch, but then the effect knows its owning effect and it can trace up the error boundaries that way. So but it's actually the effect that does the catching, so to speak, right? Like it's where the sync is. The fact that an async or memo error is irrelevant if no one is listening, right? It's like if a tree falls in the woods, you know. Yeah, I think there's something here. This is still very rough. I did the Signals 2.0 stream, which you guys should check out if you haven't already, where this wasn't working at all. And now we're a little bit further along. As I said, my week was like spend a day, 2 days on this, including those write ups, spend 2 days working on Solid, one day looking at Solid Start, trying to get it on block. Like I have to time slice stuff, you know, plus whatever of work and learning I've been doing. Some onboarding stuff at Netlify. I like, yeah, I basically have to keep on juggling slices right now. I guess I'm asking if an effect has a deep-equal and only updates the fields that need because of this. Yeah, I mean, I think there's a gap in general of projecting like state, and stuff like Signia has something called like incremental computations, which can handle this. Our fork component or map array is an example of this. There, we need data to get we need data to get to be derived, right? Oh, I got a bunch of highs. Did I just get rated? Oh wow, yeah. Teacher rating with a party of 158. Wow, that's awesome. Glad to see you guys here. I was just wrapping up on showing off um, a cool new async model that I was working on for Solid 2.0 signals. Um, I was it's so funny because this is so rough that I'm doing the DOM APIs by hand. But the idea was I was like showing that if you had like a component that rendered two numbers, let's say a count and a double count, in this new model that I've been working on, if I'm going to comment this out first. If we say author that data in such a way that you know, you have a count and a double count, and then have a button that updates the count. Sorry, this is like raw DOM APIs, and then display. I'm just calling the child component basically, and I click it and it updates right away. Yay. But it's possible with this new model that that I'm working on here, so that if we introduce something async into the puzzle, like maybe double count needs to go fetch something from the server, um, and just to really bring in my point, I'm returning an object, so you can see that like this should theoretically be undefined at first. It's possible with this new reactive model to see there's a delay now between when I click and when it shows up. It's possible to, without changing the component underneath, to basically have colorless async, like not needing to null check. And yeah, it's a cool little trick because essentially, um, because it's solid and reactivity, we've actually pushed the read all the way down to the leaf node. So like if we had something like suspense here, it would actually trigger all the way down the tree without actually having to rewrite your components. Now, pretty technical topic, obviously, but yeah, this is colorless, non-blocking async, which is super relevant when we want to talk about blocking async, because I was going to talk about the React 19 thing. Yeah. So I don't know if you guys heard about that controversy at all with React 19. But they did some funny stuff with their suspense that got some people pretty upset. And I guess I don't know if there's anything else on this topic I want to talk to, but we can kind of start getting into their mindset. Well, I've just spent the last hour showing people how you could create a completely non-blocking async model, one where like literally you could have everything render except for the async piece, and then have the async piece fit in. And instead of like throwing or waiting at your component boundary, we push it right down to the leaf nodes, just like signals normally do. So you update only the things that change, only await the things that change. React model is pretty much the opposite. And they have awaits in their server components, where they block. Even I think promise all is a smell, because at least on the client, because the client, you have things updating all the time. Why would you try and block in the middle of your, obviously they don't use await in on the client components that you have used, but I'm just saying like promise all is already suggesting that you have to wait for both halves to come in together, and I want all these things firing in independently, right? But this is kind of, yeah, let's take a look at that conversation a bit. So the gist of it was, and I think this is my understanding now, is it's going to be reversed. I was actually there on the floor when they decided to make that change. Everyone is talking about it at React Summit in Amsterdam, but let's go back to the start of this. Now, I definitely need to blog about React 19 changes around suspense and sibling pre-rendering. I haven't seen anyone so far from the React core team who thinks this is the right trade-off. Version 19 isn't out yet, so maybe there's a slim chance to get them to reconsider. Basically, let me see if I actually still have it. I remade... sorry, give me 2 seconds. I haven't been in here for a while. I actually made the exact example that he's talking about. I thought I did it in Code Sandbox. Let me see if I did it. Give me 2 seconds here. Okay, this is not it. This is me helping someone debug. Maybe a stack blitz. Give me 2 seconds. It'll help with the explanation. Sorry, I haven't been on this computer for such a long time because I was traveling. React 19 suspense. That sounds like it. Okay, check this out. I'll show you the issue right now. So, picture you have a component. I love how long this is taking to load. Anyways, picture you have a component, and in your component you have a suspense fallback. And inside your suspense fallback, you have component A, component B. And component A has a component C in it. And I just had fun with this. B has D and E. It doesn't matter. I've just put a bunch of components. I made a tree. At the bottom, I have C, which fetches something. And then I have D, which fetches something. And I have E that fetches something, right? So if you look at this hierarchy, I have a suspense up here, and then I have some nested components, all siblings of each other, some in separate sibling tree like branches that are all fetching data. And with React 19, what ends up happening is I took a timestamp here, and then I subtracted the timestamp. So this is how many milliseconds between each of these components rendering. If you actually see here that I write a div with the count, I call it, but the count is, where's my fetch function, is literally the ID of the thing plus the current time minus the start time. And I'm faking a 2 second delay. So these all our siblings doing a fetch. And if I refresh this thing, you can see that it takes 6 seconds for this to load because there's clearly 2-second interval between them. 2, 4, 6. In React 18, it did not work this way. In Solid, it does not work this way. But this was the change in React 19. Anywhere in the tree that hits a use or hits something async, it just stops rendering there, which means the next thing that hits async waterfalls, and then the next thing waterfalls. And essentially something where someone writing it might think, oh, it would be if every request took 2 seconds, it'd be parallelized, it'd take 2 seconds. It's now suddenly 6 seconds. Yeah, you only cared because React got lazy, which is fair. But and this has the canary version of React 18. Yeah, see, I couldn't go back to React 18 because React 18 didn't have use, and I started doing stuff, and I was like, okay, I'm not even gonna do this. Yeah, to be honest, this is crazy. Yes, this is like bonkers crazy. Like, but it is and it isn't. I'll give you the crazy argument first because I heard it firsthand. The guys over at React 3 Fiber were one of the guys was at the conference, and he was like he's like, this is untenable. He's like, with React 3 we actually build essentially all these async resources, like building textures, building models, building part of the 3D graph. And they rely on transitions as a way of like having it really smoothly come in, while this background process is happening. However, if every async thing waterfalls, all the parallel stuff waterfalls, like basically he's like, we don't have like, half a dozen async data fetches on a page. We have hundreds of these async calls spread throughout the components setting up these resources. He's like this is just like non-starter, right? Like, can you picture having to like wait for each mesh to to actualize before moving on to the next one? Obviously, they hadn't considered this, but like there were some people who were pretty upset about it. You have to understand, in some ways, at first I thought people were overreacting because let's face it, in React, doing this, yes, it goes to siblings. But if comp A, if C was inside D, was inside D, if we had children hierarchy, yes, React would be waterfalling already anyways. Like if you fetch data in one component and then the child component fetches data, you would have a waterfall in React. You don't in Solid, but in React you do. So like I was like, okay. At first I was like, I didn't understand it completely. I was like, maybe this is a shallow thing. But no, it's literally they block anywhere in the tree. And it makes sense because it makes it consistent with server rendering. Because on the server, they don't need the parallelization. They can just async await, render to that point, then render to the next point, and render to the next point. Whereas and that's pretty efficient because nothing else updates. But in the client, as we can see, this is a little bit awkward. But let's read a little bit farther. They are overreacting. Yeah. I mean, when I saw this and I was in the meeting, I was like, you guys, there's no way this sticks. Like this has to. They have to do something about this, right? Because people were getting kind of worried, right? This is a great response from Sophie Alpert. Discussion at React Core team meeting today. Few notes. This was not motivated by RSC Vercel, but actually Facebook site, which is faster this way due to less CPU load. This simplification enabled several newer changes that would need weeks of plus work to get back, even if desired. Okay, let's keep on reading. The proper fix is a major refactor to be able to track multiple in-progress components without re-executing unnecessarily. So we have our best of both worlds. Until then, we're left with two suboptimal options. Recognize the old way is better for React query users with lazy fetches. New way is better for teams that have already structured their code to initiate earlier fetches. People who hyper-optimize performance have already done this and have a higher ceiling. Did you just listen to what they said? Just hoist it. Yes. Just hoist it. I think this will help you understand why this is such a big deal. I mean, I myself, when I reposted this, said, hopefully this doesn't come as a surprise to anyone that the answer is, no, a determining factor was that those already optimizing for performance hoisted. The thing is, hoisting makes a hell of a lot of sense. It's the reason we have loaders in Remix. It's the reason why, like, React is so easy to write it wrong. I mean, especially if you're not hoisting. I told you the difference of the depth can make all the changes. Like React server component, move a component around, suddenly you have a waterfall, right? You know, I I hoisting is the only foolproof way to do this, whether through some fancy compiler like Relay, but generally speaking, you hoist the data fetching up. I've been saying this for ages, but there was opposition to this statement. And do you know where that opposition came from? React. No, local data fetching is fine, blah, 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 blah. And I guess they were talking about server components, to be fair. Server waterfalls aren't as bad as other waterfalls. But this is like an acknowledgement here that they do hoist. This is the first I've actually seen that, because I mean I was in a conversation, like multiple Twitter spaces with Dan Abramoff, going on and on and on about how like hoisting is not a good solution to this problem, and it's like, oh yeah, but we hoist. like like this is, as I said, it should be obvious, but like a lot of people purposely did not. Like if you talk to the Alex from TRPC is a perfect example. Like obviously this is a surprise, this change. He said, I hoisted intentionally when I knew there'd be a waterfall. That's fine. But like the whole TANStack query side of the world, there's a whole basically push to people being able to just local data fetch. And the thing is, reality is it could never be the optimal solution, especially with the way React blocks. Do as I say, not as I do. Now, I don't know. I can't find anything where the core team, like in writing, pretty much said this stuff. But there was, when I was kicking a fuss about waterfalls, there was so many conversations saying like, "Oh no, local's better. You just do it." And I'm like, "Well, you had the hoist on the client anyway." And they're like, "No, we never hoist on the client." Blah blah. I'm just like, but it's like, of course, Facebook or Meta hoists. Like, yeah, I think the only people who have an illusion about this are like a certain, group of people like on Twitter or something. Like yeah, Relay doesn't work on the hoisting. Yeah, Relay is, I mean, and that's been the thing, right? Internally, they have Relay to do the hoisting for them, right? So like, yeah, I haven't seen the latest Theo video, so probably, I guess, yeah, I'm a little late on this. I was away, but like the thing is, I get why they made this decision, right? I hope you guys can get too. Let's look back in this example. Think about what React has to do in this example. Let's pretend it's ABC. React is a re-render based framework. So if you've already hoisted your data and you get here and you go render, you go component A, you see the async thing and you're like, okay, I can't go any further. Then you go to component B. So you go to component A, you go into component C, and then you go, okay, I see the async thing and you can't go any further. And then they go to component B, and then they go to component D, and they go, okay, I can't go any further. And then they go to component E, and then they go, I can't go any further. And then guess what happens? A comes back. And guess what? So then they go to component A and they're like, okay, sweet, I can render it. And they finish component A. And then, like, I don't know how many times in the cycle they do it. I would be interested to test um, the test with um, React 18 or an older version that actually had this behavior. But my point is, because they have to do a re-render model, they end up re-rendering as the stuff comes in. They have no choice to. So they render everything initially, and then they have to render it everything again when suspense finishes. So they were thinking, well, what if we got to A and we just stopped? Now we're not rendering B, and we're not rendering D and E and the rest of the component tree. And then we continue, and then we get to D, and then we stop. You know, like basically with this model, they only have to render every component once through the course of suspense. They might have to like re-render the component itself, like when they like stop and then they continue, but they don't have to render the whole component tree under the suspense again. And with the old model, the model people want, they basically were completely re-rendering the tree, some amount of times. I don't know if it was with every resolution or if it was certain them, but they were doing a lot of re-rendering for stuff that no one will ever see. So, at Meta, some of that work is expensive, I guess. Right? I'm even if it's, performance optimized, there must be a cost to rendering React components. That's the second takeaway from this that I found interesting, because you wouldn't make this optimization if you didn't recognize that there's an overhead to rendering React components. Even without doing the side effects, even without doing the DOM diff or whatever, rendering in React has a cost. We like to pretend that it doesn't have a cost. Oh, it's not important. But it was enough for them to make this optimization at Meta, just putting it out there. So, yeah, I mean, I found this situation very illuminating because it both acknowledged the need for hoisting and that React components in a vacuum have a real render cost that needs to be considered at scale. I'm just throwing it out there, right? Like, that would have been my hunch, but I can't speak to Meta's scale, but I'm glad they've been able to speak for us. It could be, but like, think about it. What's if their code is well written, maybe it has a compiler in there or something, they're going to memoize the code. They're going to create the hooks are going to be there. Yes, the initial creation it's there, but if you render it again and nothing's changed, then you're just pulling from the same source. I would think maybe there's a technical piece I'm missing here on that made this exceptionally more expensive, but otherwise, I would think that they wouldn't have to do all the work on re-renders here either. Right? Like, they don't have to run most of the app code because like that's why React renders are cheap, because they don't have to you do all the app code work every single time. That's why you have hooks, right? Like, that's what makes it comparable, because if React had to run all the app code like every time it rendered, it would be incredibly slow, right? Wouldn't it? They try to only run what changes. Right, but is it the first render every time? If it's the first render every time, then yeah, I think that's pretty legit. Like, if both when they do the first render, because like you could argue that first render doesn't matter that much. Like, I made this argument actually with solid suspense solution, because if you're waiting on the async anyways, yes, yeah, the rest of the work is going off into space, but no one's waiting on it. Do you know what I mean? Like, but if the second render, like when the stuff comes back, or any subsequent render when stuff comes back, is like the first render again when suspense finishes, then yes, I could see why the expense would be more. Right? Because then it would treat it not as re-renders. I don't know if I want to look at this. I'm going to. Was this an actual meme? I mean, I love it, but was this an actual meme? Yeah. Uh, anyway, thank you for that. Yeah, I mean, I don't think they care about re-renders though. The optimization about showing the fallback as quickly as possible. Yeah. Okay. Yeah, I'll accept that. Right. As we said, all the pure stage stuff could be a blocker, and they can't show the fallback you can't show the fallback until you get to the end. So they're literally seeing it. They're probably literally seeing a gap between, like, very small, maybe in the fraction, like tens to hundreds of milliseconds between showing the fallback for exceptionally large things. Okay, yeah, that makes sense to me. But yeah, I mean, it yeah, it's interesting because, like, to be fair, if you were to parallelize this, you would still have this delay to show the fallback. I guess. I guess this is an interesting scenario in React land at Meta where the synchronous work is so much that it can actually delay synchronous work, which is pretty challenging, right? To deal with. Like, if you're like, because, like, the only way to look ahead is to render ahead, right? Like, there's no avoiding that. Whether you're solid, whether you're React, whatever, you're going to render ahead to look ahead. I taken that for granted from the perspective of that if I render ahead, I get to save that work. Next time when the data updates, I don't have to re-render anything. It's solid. You re-render once. But I was assuming that React didn't want to go that way because obviously, they'd have to redo a bunch of work. But the argument that the initial sync data to render was slow enough to delay the fallback is interesting. That being said, it's kind of true of anything, right? Like, if that stuff wasn't async, it would also take just as long to render. So, yeah, maybe it's just like one of those, like, cheeky little optimizations. I love them too, right? You do that, and then you're like, you get to save at a place you wouldn't usually get to save. So, anyway, still very, very illuminating conversation, I have to admit. Okay, let's finish this. I think our documentation around how to structure your fetches, when to fetch, if not, your server isn't good enough. That's true. Ultimately, I recognize your frustration, for frustration too, but also recognize it's not an easy fix that's better for everyone. I wish I had better news to report, but yeah. Good news, we care a lot about spas. Team misjudged how many people rely on this today. Still recommend preloading, but recognize not always practical. Plan the whole 19 release until we get a good fix. Yeah. It is. Yeah. Yeah. There isn't like an amazing fix for this, though, I don't think. Because you still got to render to render, right? And in any case, I'm glad that, like, a good outcome came out of it. This is a great example of community outcry leading to something. So yeah, I'm trying to remember. Did I have any more notes? Yeah, no, not really. People are asking. I don't get why React moved away from their loader like POC. Well, the problem is this doesn't feel natural. Yeah, I mean, it's hard to be too prescriptive around data fetching patterns. People have to have some choice, and at the core level, I can understand why React wouldn't want to do that. All right. Okay. It's funny. This is a mixed bag today, so we're just gonna wrap up on this week in JavaScript. Then I'm just gonna. I don't have a header today. We're just gonna continue with some of the posts I put aside. So let's continue along that. We talked about benchmarking. We talked about the compiler. Yeah, everyone likes that demo. My problem is I think everyone who likes that demo has no clue about RSCs. It's it's kind of unfortunate. I can understand why the React team was kind of hesitant here, but then they're like, okay, well, Remix is at least adopting them. Maybe this will change the narrative. It's like there's so much not. Yeah, I'm I, I, I'm. It's kind of interesting because it's an example where people are like, yeah, this is how they should have been, and it's like, actually, no. You know, Next has RSCs mostly right. There's some details, but like, there's a reason they are the way they are. And it's if they weren't that way, then you'd probably want a different solution. Okay, so let me open up a few other things here. Just a second. I want to make sure I got my stuff. So I got let's go. Boom, boom, boom. Good. Okay. Just give me a second. I got one on bookmarks, one on my profile, and then I'm going to put one on solid.js. Okay, cool. I mean, it's one of those, like, I guess I'm just talking from a purist standpoint. It's I'm trying to think of a good analogy for this because it's like it Remix is fine. It's just like there's a React's trying to introduce a new architecture, one that I would argue is as significant as moving to single page apps in the first place from Rails, and like people are just like not getting that point. Well, I mean, this is what I've been struggling with. Like, don't think that like what Remix is doing isn't like what Remix did is actually very similar to what Nuxt did actually, and some degree what Waku tried to do initially. Like this isn't new news to me. I know it helped people, and Ryan Florence is a great speaker, but like this Lakes thing has been floating around. Even Jamie Kyle, you know, when they were at the Critter Babel or whatever, he was on Twitter saying like, "This is how I want server components to be," and he was basically describing this solution like two years ago. This is like, there's a reason they're not like that. Do you know what I mean? Like, so it's like it's it's backwards, and the primary benefit, like, um, I was talking earlier about pushing the interactivity to the leaves or thin layers. This puts the interactivity at the root. It's like it's just doesn't, at least with their guarantees in terms of loaders, like in terms of it being at the route level, you don't have to worry about fetch cascades, which is a problem when people just let anyone interject server components anywhere. But the challenge again is like the layouts become client components, which makes no sense, right? If they support use client as well, then I mean it's fine. I would just build my Remix apps the same way that I build my Next apps, and just basically forget that there's a default export and just build everything from the loader, right? Like that's essentially, you want the root to be, but then I'd be using use client in there as well, like projecting server content, client content, having client content project server being projected into the server content is fine, but it also like it's like it's the wrong banding. I don't. It's fine. Um. Anyways, okay. Let me just scroll a bit and see what I want to talk about. Yeah, let's get back to here, where are we? No, their loaders return server components. I showed this a bit last stream, but essentially you have a remix loader. It can return server components, and then basically when you use your loader data, when you go like use loader data, you get server components back, and then you can inject those into your client page. Yeah, it's a migration path version, but like anyone who's been following the stream, I've been spending a year trying to figure out if there's a hybrid universal model. That's not it. Like, I mean, it's fine, but it defeats the purpose of server components enough that I don't think it matters. Like, that's the way I'd implement server components if I want to be like, hey guys, I got server components. Check. Okay, forget about those. Like it's novel, but it's also kind of like who cares? Like, I I mean, if that's their intention with that, they are freaking geniuses because you don't really adopt the composability in the same way when you do that way. I mean, I already said that I don't think server components are actually composable, so like that aligns. I think me and Brian Florence agree about a lot of things, so I don't know, but like if I was being a pessimistic, kind of sarcastic kind of person here, I I might even take this approach as just a way of placating people when they don't actually really believe in them. Maybe, right? So yeah, I mean maybe it's the smartest move. I think the problem for any React framework right now is that, and this includes Astro to a degree. People go, well, I want to choose a React framework because React tells me to choose a framework. So I want to choose a framework that I know will support React into the future. And if you don't support RSCs or you aren't fully React, it's like a bad stigma. Like if you're, where if you go, oh, I want to support React the best way possible, I have to use Next.js because Next.js supports blank. If Remix doesn't support the stuff coming from the React core team along those lines, it looks like they're not the blessed path. So it's an interesting tension to walk, right? And I said it affects Astro because, on a certain degree, like Astro will never be the best way to create React apps from React's perspective. They'll never vet it. There's a reason it's not on the first page of the docs. When you go into how to, they recommend Gatsby, Remix, and Next. Astro's on the other page. You know what I mean? Like nobody wants to be pushed off onto that other page. So like I do think that like there's you can drag your feet for a while, you can do whatever needs to be done, but like I do get that sense. Yeah, I definitely agree. But on the other hand, I don't know who. It's not like you can blame one side either way. React has been building all this, like at the same time Remix was building all these APIs, React Core was also building them. It's not like, I know React released them later, but we all knew they were coming, right? I knew this because React actually released documents showing, what was coming, working groups, all these kind of things. So when I built a bunch of features into Solid, I kind of copied, inspired by React, whatever you want to take, into adding transitions and stuff. But then we released them. And then we built our whole ecosystem, including the router, on these primitives back in 2019, 2020. So at the exact same time, Remix was building all their features. I was sitting there building the exact same features or our versions into Solid Router, except I had the primitives that were coming in React years later. So, stuff that hasn't even come completely now because we're seeing like the gap on the client side data fetching story. I had client side data fetching story. So like I watched this play out, and the whole time it was like, oh man, all these really cool things they do with action and all that. You literally go like use transaction and you delete like 3/4 of the code. Their transition loading states, again, suspense. It's like all these things were but they couldn't access them because they weren't ready. So they were in a really hard place. Do you wait for React or do you build different versions? So while React team is very gracious and there were influences definitely, like Remix's direction helped shape. I think optimistic updates from Remix, everyone copied. Everyone knew. My gut is everyone knew there was going to be something like actions, right? It was obvious to me in 2020 when I first added, the RPC style versions to Solid Start. We had, or was it no 2021? We had a version of server actions. They weren't compiled, but they were proxy based, like right from 2021, and like it was. I think people could kind of feel that was the direction. The React core team has got a good pulse on this, but I think like the optimistic updates Remix showed with the progressive enhancement was genius. And I think stuff did back influence them, but I think React was already on this thing. They knew they needed nested routing. They knew needed these pieces. I knew I needed these pieces. I think it was dead obvious. But the problem is Remix couldn't wait for React to deliver these pieces, even though everyone knew that React was building this stuff. Right. So like this is yeah, I don't know much about React actions. How do they different from our actions? I didn't really catch the difference. I probably should look into that. I saw the release and I was just like, okay. I saw that they had a way to like natively support stuff, but I didn't look too close into it. Right. But the yeah, yeah. I mean, it's a tricky place to be in when talking about like the remix scenario. Um, Yeah, to be okay. Sorry, I missed this part. Yeah, taint is tricky in general because you can like we were playing with something with Bling on a compiler side, but you also have to handle references coming out. You have to tell the serializer. In our case, and React case, I think we own the serializer, so like we have some power there. I was talking to Alexis to see if we can do something like taint right at the serializer level. I think that's really the only way to go. Again, this is the advantage of being dialed into the core team. Oh yeah, 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 yeah. Oh yeah, they added. Oh, you're talking about the Zod stuff, right? Right, right. Yeah, yeah, that makes sense. Yeah, yeah. I mean, the protocol for server RPCs is framework agnostic. You don't actually need. That's why we were building Bling. You don't need to be tied to a framework, but actions are tied to routing, right? So if you have a React or Solid framework, they have to be somewhat router aware. So yeah, I don't see how you do it in a framework agnostic way unless your framework is framework agnostic to begin with, like Astro is, right? Like they can do it because it's tied to Astro's approach to routing. Yeah, that makes sense. But yeah, the Zod validations is clever. It's tricky. It's one of those things that it's like I don't know. Sometimes adding like we have a version with Zod validations in our ecosystem. I think it's called PRPC, which takes our server functions and adds Zod validations. But it's like building that core is making a big assumption. Well, first it assumes Zod, and to a certain degree, I don't know. I'm sure they can make it extensible. Like for example, I'm big on the Valibot on this side. It's extremely smaller, and I think it's faster too than Zod. Like tying to specific libraries is a dangerous proposition. You have to consider about. But anyway, let's. I'm just diving down specific. Let's keep on moving on. Um. Anyways, yeah. So I got a few more. Let's get a few more discussions. See if there's any more hot topics we want to talk about. Right. Okay. So when did I last stream? Let's keep on going. Pitch Solid at Amazon. That's cool. Um, I don't know why I grabbed this Adam Rack's post. He complains about everything. He's talking about how caching invalidation is really poor with RSCs, and uh, it's just because of the render model. Everything needs to be cached. I'm not worried about that. We already talked about. Okay, this is a good tweet. And I think it's important because it's related to what we were talking about with suspense. We never released official suspense support in the client because it leads to client waterfalls. Instead, we shifted to an RSC strategy. I'll let you read between the lines. Oh man, TK Dodo is great. Okay, everyone, you can use suspense for data fetching now. Okay, I get what he's saying. On like Seb working through RSCs, working through this stuff. I heard this from Dan too. They were not happy with data fetching waterfalls, which is why they never made like a create resource API, or like they never made like a like we had. They showed a hypothetical one in one of their early experiments, but they never released it. So from that perspective, even use didn't come out until React 19. So like from that perspective, I can see what he's saying here. What's interesting though is that they did trying to support third-party libraries like React Query be all like, hey, you guys, you can use suspense today simply by using lazy, or use one of our partners. And they push people to use, if they want to use suspense, to use React Query, use a few of the other libraries out there. And I remember that. I remember them being like really excited, like, look, we support suspense. And like it was the only way to use suspense in React during the React 18 time period. So while I get that they said it wasn't official, there was definitely like messaging that was like, you can use suspense today with these solutions in the client. So yeah, I can understand why it's awkward from the ecosystem standpoint, but it's also like, yeah, I think it's interesting. I I think perspectives have changed a lot over the last couple of years, and I think people probably need to kind of acknowledge that even the React team is learning, right? I'm very thankful that React rolled back in 19 Suspense Gate. We're willing to work with us. I think the future is bright as ever. Now, this is where I go next. I'm increasingly concerned how much React is pushing render as you fetch, hoisting plus preloading as the blessed, and last week almost required too soon approach for client-side data fetching despite the current state of the ecosystem. Regardless of the library you use to fetch client-side data, if you're not using a framework SSR level route loader or async paradigm, your solution probably resembles some kind of hook. I'm happy about the concern for blah, blah, blah. Relay is one of the few libraries. You could argue, yeah. Co-location on the hand feels natural, blah, blah, blah. Think about server components would feel nicely. My point is RSCs are not the only answer to co-located data fetching and honestly still require some kind of hoisting convention, blah, blah, blah. I'd like to see more attention going to retaining some of the awesome DX being able to co-locate data requirements and uses. Which is why blah, blah, blah. Sorry. Yeah, this is a great post from Tanner. Please don't kill co-location. Well, I will say to him this much: while they shouldn't kill it, it's never going to be guaranteed to be optimal, and usually the mental overhead of knowing that is probably not worth it. Yeah, we don't have to kill it, but we have to be aware that it's probably not great. I know everyone pushed this way, but like I think the Remix guys were some of the first in the React community to really be like, we need loaders, But it took them a while to even get them into the router, right? Whereas like Svelte, Solid, we already knew this, and we'd already like knew that this was valuable even on the client side. I think everyone knew this or should have. I don't know how the dialogue got so far where people thought they didn't need to hoist. It's kind of crazy to me, but it is what it is. Oh, we had Aiden here earlier. I should have asked him what this meant. I am. I know what it means. He was just saying. Remember, I told you before earlier in the stream that I couldn't figure out how to look at React compiler and figure out what actually runs. because I couldn't introspect because the compiler would remove all my introspection. It looks like Aiden's found a way around it, where he's using his own compiler tricks, probably, and his own profiler to actually be able to tell you what the hell's going on here, which is actually just lovely because this is pretty cool. Obviously, this is for his performance tool that he's building with Million to help increase the performance of your React app to show you where those pitfalls are. But yes, thank you, Aiden, for. I think if I should look at this a bit more so I can actually show the difference between reactive rendering and solids rendering. I wonder if there's a way that I could like use his tool on Solid as well, and then we could compare straight up because I think that might be the only way that I could fairly show the difference between signals and that there is a difference. I just can't show it, but this would show the difference. No, people co-locate because if your tree gets bigger or large enough, you start getting duplication when you split. Anyone who's used large MVC applications, especially stuff that we are doing around like 2010 on the client, you get to a point where you're like recreating. If you're not careful, you're recreating like view state in this other tree if you don't co-locate. There's definitely a balance here. The things aren't one for one. Like there's overlap. I don't think we kill all co-location, but I think data fetching does need to be hoisted up to appropriate nodes. That's my perspective. But otherwise, if you pull out too much, there's a lot of duplication. That sounds like a lot of fun. There's a certain chicken and the egg problem I'm going to identify with React on this side. Dev tools might, if they waited for everything to be ready, no one would adopt. Like it'd take forever. Like they need people to be on board to help build these things. Part of this, you saw with hooks too. They rely on the community to propagate stuff in out there. I rely on the community. Like sure, React's development manpower might be in the ballpark. Like the like actual paid people around Meta and Vercel working on React might be in the ballpark of let's estimate about 50 times more resources than I have working on Solid, maybe 80 times more. But even with that many resources, you can't get everything perfect. You need the community is like a 10,000x multiplier on this. Do you know what I mean? Like, so I think they released RSCs at a fairly reasonable time. That I think they had to be careful around messaging and what was production ready. But other than that, they had to get them out there at that time to get to the adoption where they are now. Yeah, Next as a product has to worry about that. React as a core team, I think, tried to get stuff out at a reasonable rate. Right. What else we got here? I wonder. Yeah, do we want to talk about that yet? Yeah. Okay. Yeah. Let me look here. Some solid stuff. More components. I love the ecosystem just keeps on growing. Every time I look, there's like a new template. Okay, official solid start template in Code Sandbox. Lovely. I'm just doing some solid news. For a moment, QTUI, solid rendering native C+. I get it giggles every time I see people do crazy stuff like this. Where like, because like, who would have thought a JavaScript framework was going to be running native code? And I know React does this, but a lot of people also thought it was because React's VDOM. Well, news, it's not. And it's just so cool to build something, as a JavaScript developer who, just builds websites and then see people make like these native applications. And you're just like, this is nuts. Anyway, I don't even know what this means, but maybe someone in chat can tell me. I think Solid.js is the Apex twins of frameworks. Real people get it. Inspired everyone. Super underrated. Thanks, Ben Holmes. I think that's really high praise. I just don't know anything about it. Yeah, see, pragmatic dropping drop. All these posts are people porting libraries. I'm stoked for our ecosystem. Our weakness on ecosystem obviously is jobs and training and teaching and that side of things. But the libraries just keep on coming. Yeah, I have no clue. Absolutely no clue. It's a less known electronic band. Okay. I listen to punk rock, heavy metal, and like death metal. I don't, and some amount of pop, but yeah, I don't know electronic and I don't know hip hop or rap or whatever. Um, yeah, I don't know. People could there's okay. I guess we're just caught up here. I one more shout out, which is kind of cool. I don't. The team at VoxLab deployed Vote Compass for the upcoming election. Answer the number of questions and learn. So the UK election company software is built in Solid. That's a lot of users. I'm excited to see this in action. Anyway, okay, that's my Solid news update. Let's go back to a couple more. Let's talk about JS survey came in. JS. I made a solid website for someone and he made me remake it because of a auth library like Clerk. Okay, but it wasn't Clerk because I think we have good solutions in the Clerk space, um, or reasonable ones. But yeah, if they, it's interesting. I guess very specific libraries makes things hard. So, like, if there's like a specific requirement, yeah, I did that earlier. We actually started the stream with that. Solid with Quickify. Yeah, I'm actually interested the other way around. It's funny, before Quickify came out or any of that, I made a code sandbox to show how it could be done with Solid. I wrote it like 3 years ago. I'm just I Getting React's ecosystem libraries is like mostly the last thing you want to do. I understand in that case that's probably like where you want to be, I guess. You have no choice, unfortunately. But like you don't want the Preact thing to happen. You don't want everyone just to like start using React libraries and not building libraries there, because React libraries will never be the good solution for you ever. So it's like it's really awkward, right? Like think about Quick, like small, fast, partial, and then you get React, and you're just like, oh, like it's like the antithesis. Like if someone has to use a React library, like you're like, okay, I begrudgingly accept it, but it's like the last thing a Quick app wants on its page is anything React. Maybe hard to say. I'm hoping it will have to be after Veet 6. The reason Sol started is the way that it is largely because we needed multiple builds and environments, and getting that in Dev and Nitro is difficult. So we can't have Dev and Nitro, which means we can't have full Nitro, and hence the whole thing. Veet 6 is a big part of changing that. Like we needed what Vinci does in order to power the stuff we do, which means that like yeah, we need Veet to upgrade to Nitro update. I'm glad that Vinci has influenced Veet so that we can do it, but until that happens, it's like just not possible. This is probably his pumpkin. Who did the? All right. Anyway, we got a couple more before I'm done here. JS framework or JS survey came out again. I see that Rich Harris likes my view of the chart. It's funny. Back in the day, they only had rank. They did not have value. So it was always these very defined differences. And he's saying Svelte is the most interesting framework consistently since it came out, which is pretty cool. It means that of people who have not used it, people are interested in learning it. If you look for Solid, Solid was third, was second couple years ago. Last year was third behind Quick, and then is back to second again this year. So this is a really good metric to show that people like the onboarding part of your marketing is working. Like that people who haven't used your framework before really are interested in it. I mean, um, yeah, is this interest or positivity? Yeah. And I think it makes a lot of sense. I think Svelte is one of the more interesting solutions out there, definitely from that perspective. Um, I also did one of those ones as well. This used to be the front page. It used to be satisfaction. And this is the metric we care about on the solid side. Felt interest. I think that retention is based on of people who have used it, who would use it again, like who liked using it. And again, when you have a smaller user base, this makes sense, but it means that solid for the third year in a row, users of solid are the happiest users. Svelte is right behind. Like we're basically neck and neck on interest and on satisfaction. So I'm like not surprised. Svelte is more known to people, so more people are interested in learning about it. Solid has smaller user base than Svelte, so more people are happy using it. So it's kind of here nor there. But it was fun looking at the survey. I don't have time to go too deep into it, but um, there are parts of the survey that have made me a little bit more pessimistic. Um, Solid is for people who like JSX, sells people who don't. Basically, so is a great thing for WordPress folk that need more. You guys are just okay. In any case, I don't know. One thing that's alarming is something. Let's see if I can pull this up real quick. JS state of Fred K. Scott tipped me off onto something, and I think this is really worth talking about in terms of libraries here. There's this. No, where is it? I want to this chart. I want to just talk about this for a moment. Fred pays a lot of attention to this because, generally speaking, you start down here at neutral in terms of negative opinions, and then you want to get to positive opinions as your usage goes up, right? If you're really high up here, it's natural that as your usage goes up, things swing back. It's a crescent, so to speak, and you could see some interesting frameworks like that kind of just go like this off. The thing that concerns me, and Fred mentioned it too, is frameworks. The sentiment is going more like we should be heading this way in this arc. And if you look at it, a perfect example is this V test. And I think this one here is Vite, right? Where you see these things arcing up like this. But that's not what's happened. Playwright's another one. That's not what's happening right now. What we're seeing is a lot of tools are turning further left sooner than they should be. What like I don't know, is that Svelte? Turbo repo. This lower corner used to be full of hope, but look at this. Here's solid. June. We're already boomeranging back according to this slightly. Not much, but it's something that I'm looking at. Tory's okay. Look at Remix. Remix is just going straight backwards. Quick is just going straight backwards. Like I think this sentiment down here in this corner, Turbo Pack, straight backwards. Turbo Repo, less so. I think people right now are less accepting of new things this year. And I think this might look Svelte boomeranging too. This last year was hopeful. Everything was kind of coming up, curving up. This year, things, with exception to a few things, like look, Astro is still positive, but most of these early projects now are boomeranging back hard. And or like as I said, they're just like going straight backwards, like Remix or Quick is, and it's like it's kind of concerning. I'm going to put out there the huge one going back. I mean, Webpack. What else? There, Mocha. Ones that are going back down are like the worst. Parcel, another one. Gatsby, Cordova. But being here isn't even bad. This is expected. This is your end of life cycle. If you're at the top heading backwards, you did a good job. Like, you get the standing ovation on the way back. It's very troubling when this side can't keep going and they get pushed over too soon. It's very troubling. Yeah. 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 People. Yeah. Yeah. I mean, the ones that are most concerning, obviously, is if you go straight back, but like, this is, I'm hoping things pull out of it. But right now, it looks like in general, people are less open to new solutions as they were the last 2 years, which is something that I keep my eye on. Anyways, that's my takeaway here. So I don't know. I'm paying attention to this for all the good stuff. That's in here. There is that. Okay. Okay. We talked about stated JavaScript. We talked. Okay, that's good on that. Let me look at my solid. I think I'm just on bookmarks now. Oh no, there's one more. Yeah. So this was an interesting conversation. I don't know to get into it, but it is about this, right? Where why do you think Svelte is not more popular given these constantly positive results? And then people are like ecosystem's hard. It's been 5 years. This discount, it's been more than 5 years, it's been like 7 years with Svelte, but 5 years since Svelte 3. This is discount you pride at the start, not a reason. You would never hear someone say Angular has a huge vendor lock-in in a conversation. People love Svelte. Why is it not adopted frequently? People want to use Svelte, but the business reality seems that cycle update new frameworks are longer than a few years. Again, historically, this is not true, but even greenfield projects are not rare and not subject to this limitation. He's right. People aren't choosing new frameworks for greenfield, which is crazy. I talked about this before. My naive assumption that it does not have to feature maturity for another place, but I want more informed. No, it's not that. But if you look at the last 8 years, it's more than technology or features. When you consider how quickly people adopted React back in 2014 compared to the maturity of the tools right now, it isn't even close. Modern tools are miles ahead in that regard. People, job market wants stability. There's a perception that JS is constantly evolving because it is, and it isn't a fear about best practices. React changes every few years. They just want to go to the answer to consolidate. What does Rich say here? Question of saturation. Yeah, I mean, it is mind-boggling, this change of sentiment, right? It's like people were pessimistic and then they were kind of hopeful, but now they're pessimistic again because the economy, probably they're not trying new things. And I think that, like, yeah, this is just it's a tricky place to be in, that people aren't even choosing arguably better solutions for greenfield. We talked about the compiler. Tenor, I don't have much to say this. He's basically describing something we had in solid for years, which I already talked about. Okay, that just leaves one thing. I think there's a situation where you used React system with a package for almost everything. Well, the funny thing is React set what those everythings were. There wasn't a package for everything when people adopted React. There wasn't even for the first 3 or 4 years. It's just, and the packages that matter in React actually do change rapidly over time. Like I always use Shadsy and as an example where it's like came out of nowhere and then everyone had to use it. So it's like I don't know. No one got fired for selecting Vue in 2014. People got fired because they selected Vue 2 in 2020. Yep, exactly. But yeah, it is weird. What do I got? I'm glad there's type of syntax discussion happening now. I've tried to explain why solid worked the way it does for ages and was met with developer has to write parentheses. Yeah, that's because it's consistent. What is actually happening? Yeah, this is just. There's been some syntax conversations. I'm glad that they're switching around. This is my last little bit. I don't really care about syntax that much. Like when someone goes, which one of these seems more like HTML? This or this? Like, this is such a loaded question because obviously this is syntactic HTML, but this V model is whatever the hell that is. And then this obviously is JSX. So it isn't. But it's like, who cares? Like, I think when people ask this question, they're sort of implying that people actually care that it's like HTML, where in 99% of the cases it doesn't matter, it's like HTML. What's actually interesting is what V model is, but whatever. Like, we all like ref in JSX. What the hell is that? Like, there's always some kind of special thing. So I don't know. So like, this is an example of the type of syntax conversations that I get pulled into that really don't matter. This is an interesting conversation because there's a conversation where Evan said something about low cognitive overhead of assignment based reactivity. Also, compiler approach is too magical. Work against competition. Works well for Svelte's audience, but blah blah blah. Because they were talking about why Vue didn't do the ref sugar like Svelte style. And then Rich, and Evan's like, composition API works exactly the same in and outside of Vue components. And then he showed this example, which is kind of mind-boggling. Rich was like, look, if I render uppercase, it works. But if I put message here, it does object. And you're like, but message is a computed. Why doesn't it automatically unwrap? But message, lowercase, is also ref. And yet I can call a function on it and treat it like it isn't actually, like, where's the dot value? Where's the function call? Like, this is kind of bonkers that this works almost exactly the opposite way. Like, they actually see the symbol and compile it, but here they don't. I don't even know how this works, to be honest, right? And obviously he shows in Svelte, it's the same in both cases. But it is an interesting thing that Svelte is all magic all the time, and it comes with those limitations that they've classically had. Vue is magic sometimes for convenience, but it causes weird inconsistencies. And then in Solid's case, we're like, just freaking call the function, So I don't know. I'm glad this is where conversations have gone on syntax, unless of this. Although, to be fair, this has 1,000 views at this point, and I probably aided in that, where this conversation probably has 80. So I don't know. I want more of this because I think syntax for a reason is interesting. I think this actually is completely pointless. I actually responded to this just to be facetious, just to be kind of annoying, where I was just like, seems like HTML definitely A. Is it desirable to have something seem like it's not? Because, like, let's face it, this stuff all gets compiled to JavaScript in the end. Who cares? And some people brought up no build reasons and all this, but like, sure, and if people, but let's face it, if you're using Vue, if you're using it no build, you're probably not going to use JSX anyways. You're going to use like HTM by Preact or whatever. And if you're using Vue, you're going to use a build step and you're going to compile this stuff to crap anyways to get the performance and the bundle you want. So it's like, this is like the most meaningless difference in the world. B model is worth arguing over. The fact that this is HTML does not matter. People who like A think that Alpert and B are a viable option. Yeah, that's funny. Stealth is simple and complex. Solid is harder and simple. Vue is the middle. Yeah, kind of. Svelte 5 is going to be interesting because it's kind of like Solid, but like a tiny bit more magical. That's going to put it in a really weird place for Vue because it's, yeah, I don't know. I guess we're going to have to see how that plays out. Anyways, I got to go. It is after 5. We've been going for 5 hours. I've been going too long. But, it's been a while. I missed you guys. So clearly, pretty clear at this point, because given how long I've been streaming here, there was more content than I thought. I sort of got lost in the weeds a little bit on some of the async stuff, but it happens. I'm hoping you got something out of it. I've been exploring this stuff. It's interesting to me. I'm really excited about the future here, but I recognize that there's a lot of pitfalls potentially. So I appreciate brainstorming this stuff with everyone. Oh, did Rich ever respond to that? Let me see. To be precise, I meant script section. More, he's saying that, yeah. What Evan's argument is that inside the template, you're like in a different zone that has different rules. And I can argue that there's a clear boundary here, whereas just random JavaScript file kind of thing is not as clear of a boundary. I guess dots felt is a clear boundary, but he's saying like, templates are allowed to have different rules, and I'm going to generally agree with him. This one doesn't make sense to me because I don't view this as purely a template thing when like I'm trying to work that out. But in general, I do agree that templates are allowed to have different rules. Anyways, yeah, sorry, I realize I'm not sharing my screen right now. You probably didn't see what I was saying, but yeah, all good. You guys have a great weekend. I will. Oh, next week's a holiday, so I won't have a stream next Friday, but hopefully you'll see me the week after. Okay, so till next time. All right.